October 3rd, 2025. NASA's Perseverance rover on the planet Mars captured visual records of 3 Atlas. These were not the clearest projections, but they were something tangible. A photographer dedicated to celestial scenes, known as Simeon Schmaus, combined 20 of those rover images. And there it materialized. A subtle luminous haze precisely where the celestial visitor from outside our solar system was anticipated. People are actively discussing it, dissecting it, and deliberating its true nature. However, here lies the peculiar aspect. On that very same date, NASA furloughed 15,000 of its personnel. The Mars Reconnaissance Orbiter's advanced imaging device, boasting a resolution 30 times superior to what Perseverance achieved, was ideally positioned for the shot of a lifetime. The European Space Agency's Mars Express and ExoMars missions were also observing. Where are those visual records? The strangeness escalates further. Observers utilizing remote viewing techniques detected evidence of technology aboard this object back in August. They described a device approximately the size of a thumb drive, deliberately housed within an ancient comet, emitting pulses. These observations were made months before telescopes began detecting the chemically improbable characteristics. This presentation is structured in 2 parts. The initial segment details 3I Atlas and all the novel revelations. The latter half provides general cosmic news from the current week. Timestamps are available in the description if you wish to skip ahead. Before we delve deeper, if you find this information compelling, please indicate your approval by liking this video and subscribing to remain informed. Kindly share your location, the current time there, and your thoughts on the true identity of this object in the comments section. Is it a natural comet or something more? If you wish to support the growth of our community, please share this content on X, Facebook, Reddit, or through your messaging applications. We appreciate your consistent support. Chapter 1: The Cylinder in the Martian Expanse. Allow me to present something that surfaced on Twitter 48 hours ago, something that profoundly altered our understanding. A user identified as UFO Mania disseminated an image accompanied by a caption that sent ripples of astonishment through the online astronomical community. The most recent and nearest of the 3 Atlas, as it traverses, is not a comet. It possesses a perfectly cylindrical form. The post included what appeared to be an elongated object captured during the Martian flyby, and within hours, it had been shared thousands of times. Now, before you dismiss this as merely another internet fabrication, comprehend what sets this apart. This was not some blurry photograph obtained from a backyard telescope. The positional data correlated, the temporal data aligned, and most crucially, the silence from official sources was consistent. Because here's what nobody's discussing. On October 3rd, as 3I Atlas made its closest approach to Mars, a distance of 29 million kilometers, we should have been inundated with visual data. The high-resolution imaging experiment camera on board NASA's Mars Reconnaissance Orbiter was perfectly oriented. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter had their instruments precisely aimed at the exact location. Multiple spacecraft, multiple vantage points, the highest resolution ever achieved for an interstellar object. And we received nothing. Well, not nothing. We received silence. But into that void stepped voices that could not be disregarded. An account known as 3I Atlas Anomaly began disseminating a technical analysis that far surpassed the usual fare of conspiracy narratives. 10 specific points were articulated, each referencing actual observations. A carbon dioxide-rich coma identified by JWST, emissions of water and hydroxyl detected by SWIFT, polarimetric anomalies exhibiting negative 2.77% polarization at a phase angle of 7 degrees, a combination unprecedented among asteroids and comets. Ponder that for a moment. This was not vague conjecture. These were references to actual instruments, actual measurements, actual scientific publications. Then came the cosmologists. A Twitter user named Moneypenny, who identifies as an expert in plasma phenomena and is a former BBC journalist, posted something that gave even skeptics pause. She asserted that a prominent cosmologist named Stephen Burns believes the object possesses intelligence, is enveloped in a dusty plasma, and demonstrates consciousness, which has already been in communication with us and with other planets. Consciousness communicating. Now, you might consider this to be venturing into fringe territory, and perhaps it is. But here's where it becomes truly intriguing. This was not disseminated in some obscure corner of the internet. It was in plain sight, with Moneypenny's credentials prominently displayed, her background in investigative journalism evident. And she added one more detail that sent a shiver down the spine of anyone paying close attention. We can no longer observe it as it is too proximate to the sun. Consequently, it will be December before we are able to view it again. December. 3 months of anticipation. 3 months during which the object remains concealed behind the sun, entirely obscured from every telescope on Earth. And during these 3 months, should its trajectory deviate, we would remain unaware until its reappearance. Then there was Jon Stewart, not the comedian, but a UFO investigator and journalist who posted something that read like a portent from another age. My source has gone incommunicado. NASA is undergoing a shutdown, and even Congress is in recess. If 3 less activates, ancient texts warn, the sky will ignite with knowing light, and the world will lose its reflection. They labeled it prophecy. The agencies refer to it as protocol. I deem it imminent. Ancient texts, Vatican files, the harbinger. These hashtags were trending alongside technical astronomical discussions. What are we to make of this? How do we distinguish the genuine signal from the overwhelming noise, especially when the noise itself might be the signal? Because here's the uncomfortable truth. In the last 48 hours, as these posts went viral, not a single official image from the Martian flyby has been released. Not from NASA, not from ESA, not from the Chinese Tianwen-1 mission or the UAE's Hope Orbiter, all of which we're observing. The sole visual evidence available to us originates from an astrophotographer named Simeon Schmaus, who meticulously combined 20 images from the Perseverance rover's Mastcam-Z camera and detected what he described as a faint smudge of light in the constellation Corona Borealis, close to the anticipated location of the comet. A faint smudge. That is all we received from humanity's closest encounter with an interstellar visitor, captured by spacecraft capable of resolving features smaller than a car on the Martian surface. We received a faint smudge, unless, of course, they observed something entirely different and deliberately chose not to reveal it. The 3 Atlas anomaly account continued to provide updates that became progressively more precise. Unexpected brightening. The object is intensifying in luminosity faster than models had predicted, suggesting more volatile or efficient outgassing mechanisms than anticipated for its distance. Spacecraft to observe during solar conjunction. As the object recedes behind the sun, terrestrial observations cease. ESA is reallocating Mars orbiters to monitor it near the October 3rd Mars flyby at an approximate distance of 30 million kilometers. Every update was technically accurate. Every detail could be corroborated against published scientific observations. And yet, the conclusion they were gradually building towards was unmistakable. This was not exhibiting the behavior of a comet. And then came the detail that no one could rationalize away: its shape. Multiple amateur astronomers, working independently, reported the same observation. When they processed their images, enhanced the contrast, and removed the background stars, what remained was not the hazy, irregular blob one would expect from a comet with an active coma. It was elongated, smooth, almost geometric, perfectly cylindrical, as UFO Mania had suggested. Now, skeptics might argue that elongation can be an artifact of motion, of image processing, of how light diffuses through a coma. And they would be correct. It can be, but it can also be real. We know this because Oumuamua, the first interstellar visitor, was also observed to be elongated. Some described it as pancake-shaped, others as cigar-shaped, but undeniably not round, certainly not what we had anticipated. So when 3I Atlas displays similar characteristics, when multiple independent observers report the same geometric quality, and when official channels remain conspicuously silent, what are we expected to infer? The response, according to NASA's carefully phrased statements, is that 3 Atlas poses no threat to Earth. Its trajectory keeps it safely hundreds of millions of kilometers distant from our planet. It will achieve its closest proximity to the Sun on October 30th, then continue its journey beyond the solar system, never to return. All of which is factually correct. All of which sidesteps the question that everyone is genuinely posing. What is it? And why, on the day we should have obtained our most comprehensive observation, Did 15,000 NASA employees receive their dismissal? Chapter 2. The Remote Viewer's Revelation. What I am about to share transpired in August of 2025, 2 months prior to the Martian flyby, preceding the shutdown, and before any of the viral posts that captured public attention. And it occurred under circumstances that render it impossible to dismiss as wishful thinking or confirmation bias. Her name is Bertie Dworsky, and if you possess any knowledge of remote viewing, you are familiar with that name. A former vice president of the Farsight Institute, with nearly 30 years of professional remote viewing experience and a master's degree in digital forensics. Not precisely the profile of someone seeking internet notoriety with outlandish assertions. In August, a friend provided her with a set of coordinates, mere numbers, devoid of any context, photographs, or news articles. This is the standard procedure for legitimate remote viewing. The target remains entirely concealed from the viewer. The remote viewer has no inkling of what they are perceiving until after the session is concluded. Bertie initiated her protocol and commenced describing what she was sensing. Her initial report was of movement through space, something in transit, something ancient, exceedingly ancient. She characterized it as a natural formation, icy and rocky, precisely what one would expect if asked to remotely view a comet. And for a period, that was its sole description. But then she perceived something unusual. There was something that was not entirely natural, she later stated in a podcast discussing her findings. There was something peculiar. The manner in which she articulated it conveyed a sense of discovering a fingerprint on something that ought to be pristine. A unique mark where only randomness should exist. She continued to delve deeper into the session, and that is when she perceived it. Something small, approximately the size of a thumb drive. Something that had been intentionally placed within this object, not on its surface, but internally. Someone had bored into this rock, she reported. Bored into this icy rock with intent and deposited something encoded with all manner of information. It's akin to an archive, a message in a bottle. But it's more than just a message, it's a form of technology. Now, pause and consider what she is describing. Not alien beings, not a colossal spacecraft, but a piece of technology the size of a thumb drive, ancient beyond measure, concealed within a comet that has traversed the galaxy for billions of years. She elaborated further, this entity is exceedingly old. And even though the object itself is billions of years old, the item that was placed within it is also very, very ancient. Did some civilization from the other side of the galaxy dispatch a small automaton to bore into it and insert their minuscule message and technology, knowing that this entity would continue its journey? This is a question that sounds like science fiction until you recall that we have undertaken precisely such endeavors. The Voyager probes carry golden records, time capsules designed to endure for billions of years in the hope that someone might eventually discover them. The concept of utilizing natural celestial bodies as vessels for messages is not at all foreign to us. We have simply not contemplated it from the inverse perspective. The friend who provided Bertie with the coordinates waited until after the session concluded to disclose what she had been remotely viewing. 3I Atlas, the interstellar object that would not even become a headline for weeks. She had been observing something that the majority of the world was not yet aware existed. But Bertie's work was not complete. She conducted 2 additional sessions, delving deeper to comprehend what she was perceiving. And in those subsequent sessions, she uncovered something that fundamentally altered the entire narrative. It is also broadcasting, she reported. These messages, she stated, are transmitted in pulses. Broadcasting in the present tense, not as something that was broadcasting billions of years ago, but as something that is broadcasting now. When the podcast host mentioned that astronomer Avi Loeb had recently published calculations indicating that 3I Atlas originated from the same sector of the sky as the renowned WOW signal from 1977, Bertie responded without hesitation. That is extremely interesting, she said. It is very plausible that this is the WOW signal. Now, you might be questioning the weight to be assigned to remote viewing testimony. It is not a conventional scientific methodology. It cannot be easily replicated or independently verified. Skeptics dismiss it outright. Believers attest to its efficacy. And the truth, as is often the case, likely resides in the complex middle ground. However, Here's what makes Birdie's account worthy of consideration. She was not alone. Multiple remote viewing groups, operating independently, focused on 3I Atlas in the months following its discovery. And while the specific details varied, certain recurring themes emerged consistently: technology, deliberate placement, transmission, and the involvement of non-human intelligence. One group reported perceiving humanoid figures associated with the object. Another described what they termed graffiti, markings, signatures. Someone had indeed left their mark. Several viewers reported a sensation of the object being intentionally obscured, deliberately evading detection, as if it did not wish to be fully perceived. One particularly detailed report referenced specialized access points, extraction sites, and a predetermined timetable. These were not vague, ethereal impressions. They were specific technical details that sounded more like an intelligence briefing than a psychic session. And then there were the more disquieting elements: references to crop circles, advanced spherical craft, hybrid warfare, invisible conflicts. The phrase brain scanning technologies appeared in multiple independent sessions. The implication was that whatever this entity was, it possessed the capability to influence minds, to incite mass hysteria or hallucinations. Now, does any of this definitively prove that 3I Atlas is anything other than a comet? Of course not. Remote viewing, even when conducted with the utmost rigor, remains within the domain of anomalous cognition, not empirical science. These are not measurements. They are not photographic evidence. They are subjective impressions filtered through human consciousness. However, they are also remarkably consistent across multiple independent viewers who had no prior contact with one another. And they align in uncanny ways with the physical anomalies that telescopes were beginning to detect. Consider what Birdie described: a small technological device, billions of years old, deliberately placed within a comet. If this were accurate, what would we anticipate observing? We would expect the object to appear as a comet from a distance, exhibiting ice, dust, and outgassing, all the typical signatures. But upon closer examination, we might notice peculiarities that do not quite align. Unusual chemical compositions, unexpected materials, behaviors that seem almost engineered rather than random. We would expect it to possess considerable mass, far exceeding its visible size, due to the presence of a dense core. Something that does not sublimate, something that remains intact regardless of how much ice vaporizes. And we might anticipate it transmitting information, not overtly, not conspicuously, but if one knew precisely where to direct their attention, if one possessed the appropriate instruments pointed in the correct direction at the opportune moment, something might be detected. A pulse, a pattern, a signal that should not be present. Birdie Dworsky perceived all of this in August, prior to the majority of the scientific data being published, before the anomalies became undeniable, and before NASA ceased its communications. She described a message in a bottle traversing the galaxy, and now, as 3I Atlas conceals itself behind the sun, as official channels refuse to release imagery from the Mars flyby, and as amateur astronomers report cylindrical shapes while scientists detect chemically impossible characteristics, that vessel is approaching perihelion, the point of maximum heat, maximum stress, the point where, as Avi Loeb articulated, confessions are elicited. If a piece of technology the size of a thumb drive is embedded within the heart of this comet, October 29th is the day it will either reveal itself or remain permanently concealed. And the fact that NASA dismissed 15,000 employees just before we were to achieve our most comprehensive observation raises a question that remote viewers have been posing since August. What did they observe that we are not being shown? Chapter 3: NASA's Deafening Silence. October 3rd, 2025 was poised to be a momentous occasion. The day humanity would achieve its closest visual encounter with an interstellar visitor. The Mars Reconnaissance Orbiter was perfectly positioned. The HiRISE camera was prepared to capture imagery with a resolution 30 times superior to anything the Hubble telescope could achieve. ESA's Mars Express and ExoMars Trace Gas orbiters stood ready with their full instrument arrays. Then, at the precise moment when humanity needed NASA the most, 83% of the agency's workforce was absent. 15,000 civil servants were furloughed, gone, during what should have been the most intensive observational campaign in the history of interstellar astronomy. The official justification provided was straightforward: a federal government shutdown, a budgetary impasse, nothing to do with 3I Atlas. Merely unfortunate timing. Unfortunate timing. These two phrases do considerable work in explaining why the world's leading space agency went dark precisely when an object exhibiting 7 statistically improbable characteristics passed within 29 million kilometers of our Martian spacecraft. Consider the probabilities of such an occurrence for a moment. 3I Atlas was detected in July. The Mars flyby had been meticulously planned for months. Scientists were aware that this would be their sole opportunity to capture high-resolution imagery before the object disappeared behind the sun. NASA was aware. ESA was aware. Every space agency on Earth was aware. And in the final week preceding the closest approach, the United States government initiated a shutdown. NASA's official website ceased its updates. Press releases were discontinued. The vast contingent of scientists who should have been diligently analyzing data, processing images, and making groundbreaking discoveries were sent home. Only essential personnel remained, forming a skeleton crew tasked with maintaining critical operations. However, here's what renders this scenario suspicious. Raw image feeds from the Perseverance rover continued to upload. The rover did not cease its operations. The Mars Reconnaissance Orbiter did not halt its functioning. The cameras remained active. Data was being collected. It simply was not being disseminated to the public. Amateur astronomer Dobsonian Power, a YouTuber utilizing a solar telescope, posted an image on October 3rd accompanied by a simple caption. What on earth is it? The image depicted something dark and angular, embedded within the anticipated position of 3I Atlas. Within hours, the post garnered thousands of views. People were demanding answers. People were pointing out that if a backyard observer could capture such an image, what were the professional instruments actually seeing? NASA remained silent. ESA remained silent. The only official confirmation that observations had indeed taken place came from Simeon Schmaus, the astrophotographer who meticulously combined 20 Perseverance images and detected that faint smudge. He shared his work on social media, not through official channels, but as a private citizen undertaking the task that space agencies had neglected. Then came the White House press briefing. Stephen Miller, the Deputy Chief of Staff for Policy, was discussing the government shutdown when a reporter posed a question that had been circulating online for days. Has the president been briefed regarding 3I Atlas? The room fell silent. Miller paused, chose his words with deliberation, and offered a deflection. The briefing proceeded, but the question had been asked on camera in an official setting, signifying that it could no longer be dismissed as mere internet conjecture. The United States government was being directly questioned about an interstellar object, and they were opting not to provide an answer. Meanwhile, Avi Loeb was making appearances on news networks, including Newsmax and CBS, and on various podcasts, speaking to anyone willing to listen. He meticulously laid out the anomalies with mathematical precision, the trajectory aligning with the ecliptic plane, a probability of 0.2%. The timing optimized for planetary encounters, a probability of 0.005%. The unique attributes that distinguish the object designated 3I Atlas from all previous celestial observations were 7 in number. A single point, however, continually drew the attention of researchers. The crucial need for data from Mars orbiters was emphasized. High-resolution imagery could ascertain the nucleus's dimensions, reveal its internal structure, and ultimately resolve the fundamental question of its nature. Yet, these images were not being made public. During a podcast discussion with Brian Keating, Lowe revealed that Representative Tim Burchett, a member of the House Committee on Oversight and Accountability, had joined him on Newsmax to discuss the object. The presence of a sitting congressman on national television discussing an interstellar visitor and the unusual lack of transparency surrounding it signaled a shift from fringe speculation to mainstream political discourse. Despite this, NASA remained silent. The European Space Agency eventually issued a statement confirming that their Mars Express and ExoMars Trace Gas Orbiter missions had successfully tracked 3I Atlas during the observation window between October 1st and 7th. Their instruments, including the high-resolution stereo camera, the color and stereo surface imaging system, and various spectrometers, had gathered data slated for analysis in the ensuing weeks, with results to be published when ready. However, This confirmation lacked any images, preliminary findings, or expressions of excitement about capturing unprecedented views of an interstellar object at close range. It was merely a factual confirmation of observation followed by silence. China's Tianwen-1 mission and the UAE's Hope orbiter provided no comment. Every spacecraft in Martian orbit had been observing, and every space agency on Earth had adopted a reticent stance. This situation warranted suspicion, not necessarily from conspiracy theorists, but from anyone recalling the events surrounding 2I Borisov, the preceding interstellar comet. In 2019, following its passage, images were disseminated immediately. Scientists expressed enthusiasm, press releases were issued, and the astronomical community celebrated. It was treated precisely as one would anticipate for a rare visitor from beyond our solar system, warranting intense study and public engagement. In stark contrast, 3I Atlas was met with silence. The divergence in treatment might be attributed to 2I Borisov behaving exactly as a comet should, exhibiting the appropriate chemical composition, a visible tail, and expected outgassing patterns. While its interstellar origin was noteworthy, it presented no anomalies. It did not challenge existing scientific understanding or provoke uncomfortable inquiries. 3I Atlas, conversely, did all of these things. Consequently, as it vanished behind the Sun on its trajectory towards perihelion, entering a region of the solar system invisible to Earth-based telescopes, the silence intensified. Amateur astronomers shared their final captured images, and scientists published their findings, carefully worded, technically precise, and devoid of speculation. Meanwhile, 15,000 NASA employees waited to be recalled to duty, pondering what their colleagues with essential clearance had witnessed in the Mars orbiter imagery that the public was being denied. Chapter 4. 7 Impossibilities. Science operates on a principle known as Occam's razor. When faced with competing explanations, the simplest one is typically the most accurate. A single anomaly can be readily explained away, and 2 might be attributed to coincidence. However, when 7 statistically improbable occurrences are observed in succession, Occam's razor begins to suggest a different conclusion. Let us examine what makes 3I Atlas unlike any object ever tracked through our solar system. Anomaly 1. The mass discrepancy. Initial calculations of 3I Atlas's size, based on its brightness, yielded a result that defied logical explanation. If the observed luminosity were solely due to reflected sunlight, the object would have been estimated to be between 10 and 20 kilometers in diameter. For perspective, Oumuamua was barely 100 meters across, and 2I Borisov was less than 1 kilometer. This object appeared to be orders of magnitude larger. The prevailing statistical models, which predict the detection rates of interstellar objects, are unequivocal. Smaller objects are common, while larger ones are exceptionally rare. We should have encountered hundreds, perhaps thousands, of Oumuamua-sized visitors before encountering something as substantial as 3I Atlas. The probability of such an encounter was calculated at approximately 0.01%, or 1 in 10,000. This was followed by the astrometric data. Over 4,000 measurements, collected from 227 observatories between May and September, provided crucial information. When scientists analyzed the object's trajectory and compared it to the expected path under pure gravitational acceleration, they discovered something remarkable: a near-complete absence of deviation. Despite significant outgassing, with an estimated loss of 150 kilograms of material per second, the object hardly deviated from its predicted course. This strongly implied an immense mass, a nucleus so substantial that even continuous ejection of gas and dust could not alter its trajectory. Calculations suggested a mass exceeding 33 billion tons and a diameter greater than 5 kilometers, making it not only larger than previous interstellar visitors, but approximately 1 million times more massive than Oumuamua. 1 million times. Consider that disparity. It is akin to comparing a grain of sand to a boulder. Anomaly 2. Solar illumination anomaly. The Hubble Space Telescope captured the highest resolution image of 3I Atlas on July 21, 2025. Scientists analyzing this image observed a phenomenon never before documented in any comet, solar system, or interstellar object. The scattered light surrounding the object extended roughly twice as far towards the Sun as it did perpendicularly or in the opposite direction of the Sun. Comets typically possess tails that point away from the sun due to radiation pressure expelling dust particles. This is a fundamental principle of physics, validated by centuries of observations. 3I Atlas appeared to defy this principle, with the extension showing a pronounced 10-to-1 ratio in the solar direction compared to the sideways direction. Furthermore, this observation was made edge-on, meaning the true elongation was even more extreme when accounting for the viewing geometry. A paper published by Avib and Eric Keto proposed an explanation involving ice fragments that sublimate at varying rates depending on the side from which they are ejected. While the physics and mathematics of their explanation were sound, it necessitated a highly specific set of conditions never before observed in any other comet. This unique configuration coincidentally occurred in an interstellar visitor already exhibiting numerous other anomalies. Anomaly 3, the industrial signature. In late August and early September, the Very Large Telescope in Chile directed its UVES spectrograph towards 3I Atlas and detected a substance that stunned scientists: nickel atoms within the gas plume. A substantial amount of nickel was observed, rising exponentially as the object approached the sun, increasing by a power law of approximately 9. The perplexing issue was the near-total absence of iron. In natural cosmic processes, nickel and iron are created together in supernova explosions and typically occur in fixed ratios. Every natural comet ever observed displays similar abundances of nickel and iron. 2I Borisov, the preceding interstellar comet, exhibited normal nickel to iron ratios, as do all comets within our solar system. 3I Atlas, however, was producing nickel without commensurate amounts of iron. This specific signature is found exclusively in industrial production, specifically in nickel alloys, materials that have undergone deliberate refining and separation. The scientists who published this data were meticulous in their wording, describing it as extremely puzzling. They noted that the temperature at the object's distance from the sun was far too low to vaporize the refractory minerals containing these metals under normal circumstances. While they proposed potential chemical pathways to explain the observation, an undercurrent of uncertainty was palpable. Anomaly 4, polarization from an extraterrestrial source. When light scatters off particles, it becomes polarized. The degree and direction of this polarization provide information about the size, shape, and composition of those particles. Comets exhibit characteristic polarization signatures, which have been measured in hundreds of instances, and these patterns are well understood. 3I Atlas presented a polarization signature that did not exist in any catalog: a negative 2.77% at a phase angle of approximately 7 degrees, with an inversion angle of only 17 degrees. This combination had never been measured in any asteroid or comet, whether from our solar system or interstellar. The closest match was not with comets at all, but with trans-Neptunian objects and a specific centaur named Pholus, icy bodies originating from the outer solar system with significantly different compositions and histories than typical comets. A paper submitted to Astrophysical Journal Letters concluded that 3I Atlas might represent a distinct class of comet, thus expanding the known diversity of interstellar bodies. Distinct class is scientific terminology for an object for which no existing category is suitable. Anomaly 5, ecliptic alignment. The solar system is essentially planar, with planets orbiting within a plane known as the ecliptic. Interstellar objects arriving from random directions are expected to intersect this plane at random angles. The probability of an interstellar visitor's orbit aligning within 5 degrees of the ecliptic is approximately 0.2%, or 1 in 500. 3I Atlas arrived with an alignment within 5 degrees. Furthermore, it was moving retrograde, in the opposite direction of the planet's orbital motion. This trajectory would be considered ideal for surveying multiple planets with minimal course corrections. Anomaly 6, planetary timing. 3I Atlas was projected to pass close to 3 planets during its flyby: Venus at 0.65 astronomical units, Mars at 0.19, and Jupiter at 0.36 astronomical units. The probability of a random interstellar visitor arriving with the timing that allows for close approaches to 3 different planets is approximately 0.005%, or 1 in 20,000. If one were to design a reconnaissance mission to our solar system, this would be the preferred trajectory. Anomaly 7, the WOW signal coincidence. In 1977, The Big Ear radio telescope detected a signal so unusual that astronomer Jerry Emmon famously wrote, "Wow," in the margins. Originating from the constellation Sagittarius, it lasted 72 seconds and has never been detected again despite decades of searching. When scientists traced 3I Atlas's trajectory backward through the galaxy, accounting for its speed and direction, they calculated its position in 1977. The result placed it within 9 degrees of the WOW signal's origin. The probability of this spatial alignment is roughly 0.6%. 7 anomalies, 7 statistical long shots, and we're expected to accept them as mere coincidences. Chapter 5, October 29th, The Confession. At this very moment, as you are listening, 3I Atlas is in an unseen location, concealed behind the sun, journeying towards a point where the laws of physics are tested to their absolute limits, perihelion, its closest approach to our star. For 3I Atlas, this event occurs on October 29, 2025, at a distance of approximately 1.4 astronomical units, just inside the orbit of Mars. This proximity means the sun transitions from a distant light source to an overwhelmingly dominant presence. Imagine standing before an open blast furnace. Now, amplify that heat by an incomprehensible factor. That is the significance of perihelion for an object originating from the frigid darkness of interstellar space. Sunlight impacts the surface with gigawatts of power, not metaphorical power, but actual, measurable watts, the kind that power cities. A vibe made an observation that resonated with many. High-stress environments elicit confessions. He was referring to interrogation techniques, but the principle extends to physics as well. When ice is heated, it cannot masquerade as anything other than ice. When rock is heated, it behaves like rock. And when an object, potentially masquerading as a comet but possibly something else entirely, is subjected to intense heat, its true nature is revealed. There are 2 distinct scenarios for what might occur at perihelion, and they are diametrically opposed. Scenario 1. 3I Atlas is precisely what it appears to be, a comet. An unusually massive, chemically peculiar, and statistically improbable comet, but a natural one nonetheless. In this scenario, October 29th marks the beginning of spectacular activity. The surface temperature escalates, causing volatiles dormant for billions of years to become exposed to intense solar radiation. Carbon dioxide sublimates, water ice vaporizes, and dust particles are ejected in immense plumes. We have witnessed this phenomenon before. Comets near perihelion become magnificent, developing tails millions of kilometers long, dramatically increasing in brightness, and sometimes fragmenting under the stress, breaking into pieces that eventually disperse. It is a violent, chaotic, and breathtaking spectacle. If 3I Atlas is natural, we should anticipate a similar event, a massive outburst of gas and dust, a brightness increase of tenfold or more, and the formation of a proper tail, not an anomalous sunward glow, but a classic cometary tail streaming behind it as radiation pressure exerts its force. Moreover, if the object is as fragile as some scientists suspect, with its 5-kilometer diameter composed largely of loosely bound ice rather than solid rock, perihelion could result in its complete disintegration. We might witness in real time the disintegration of an interstellar visitor into fragments, offering an unprecedented glimpse into the internal structure of a comet from another star system. This would be extraordinary, providing invaluable insights into comet formation, the composition of planetary systems beyond our own, and the processes that eject objects into interstellar space. It would represent a scientific bonanza, even if it meant the destruction of the object under study. However, there is scenario 2. 3I Atlas is not natural. The anomalies are not coincidences. The nickel without iron, the retrograde tail, the precise alignment with the ecliptic, and the proximity to the WOW signal's origin all signify something more. In this scenario, perihelion is not about sublimation but activation. Consider what would be involved if one were to dispatch a probe to another star system. It would need to endure the journey, billions of years in the cold, exposure to radiation, impacts, and the slow passage of time. Encasing it in ice would be a logical choice. Ice is abundant, offers protection, and would make the probe appear natural to any civilization that might detect it before it was intended to be revealed. However, upon reaching the inner solar system and approaching the host star, the probe would need to activate. It would require power, and the star itself would be the only available source. In this scenario, perihelion serves not as a stress test but as a charging station. Low outlined the possibilities in his papers with mathematical precision. The object could employ a solar orbit maneuver, a real technique utilized by our own spacecraft. This involves diving close to the Sun, using its gravity to accelerate and dramatically alter trajectory with minimal fuel expenditure, representing the most efficient method for course alteration within the solar system. The optimal point for such a maneuver is at perihelion, and 3I Atlas reaches this point while completely obscured from Earth-based observation, hidden behind the Sun. If its intention were to change course undetected, this would be the opportune moment. Alternatively, it could deploy something, mini probes, small craft that detach and utilize the retrograde trajectory to intercept planets like Mars, Earth, or Jupiter, all reachable from this position with minimal course adjustments. The timing of the planetary alignments makes this almost trivially achievable compared to random arrival times. Low is careful to note the implications. If 3I Atlas maneuvers towards Earth upon reappearing on the other side of the Sun, global financial markets could collapse. This is not hyperbole but a sober assessment of the potential consequences when humanity realizes it is not alone and that the visitors might not be benign. However, we will not know for certain. Not yet. From now until early December, we are effectively blind. Every telescope on Earth and every space-based observatory are incapable of observing behind the Sun. 3I Atlas is in a communication blackout, an ideal condition for a spacecraft that wishes to conceal its next move. The European Space Agency has a contingency plan. Between November 2nd and 25th, the Jupiter Icy Moons Explorer, JUICE, spacecraft, currently en route to Jupiter, will direct its instruments towards 3I Atlas. JUICE will observe the object shortly after perihelion, when it is expected to be at its peak activity, after whatever significant events are to occur have already transpired. JUICE was not designed for comet studies. Its cameras and spectrometers are optimized for icy moons, for detecting subsurface oceans, and for analyzing the chemistry of alien water. Nevertheless, these same instruments can be used to observe 3I Atlas. Because JUICE is positioned between Earth and the Sun, it offers a viewing angle unavailable from our planet. If the object develops a massive coma and tail, JUICE will detect it. If it fragments, JUICE will document the debris field. And if it behaves unexpectedly, if it maneuvers, releases objects, or exhibits any behavior inconsistent with a natural comet, JUICE will record that as well. The data transmission will not be immediate. Space communication is time-consuming, and JUICE is far from Earth. However, by late November or early December, we will have answers, coinciding with 3I Atlas's re-emergence into Earth's view. December 19th is when the object makes its closest approach to our planet, still 1.8 astronomical units away. It poses no threat, but it will be close enough for every major observatory to track its trajectory with extreme precision. At that point, we will know if anything has changed. If the orbit precisely matches predictions from gravitational models, we can relax, accepting it as another strange but natural interstellar visitor continuing its journey back into the cosmic darkness. However, if the measurements deviate, if the trajectory shows even slight anomalies that cannot be attributed to outgassing or solar radiation pressure, then every assumption we hold about our place in the universe will require reevaluation. October 29th is the day 3I Atlas will reveal its true nature. However, we will not receive that revelation until December, and by then, it may be too late to do anything but observe the unfolding events. Chapter 6, Global Panic. While scientists engaged in data debates and NASA maintained its silence, another phenomenon was unfolding, spreading with a speed that outpaced any scientific peer review process. The internet was ablaze. The phenomenon began in the United States, as such events often do. TikTok videos surfaced, showcasing alleged images of 3I Atlas, some genuine, many fabricated, collectively amassing millions of views. Reddit threads expanded into thousands of comments, and Twitter, now known as X, transformed into a battleground between amateur astronomers sharing legitimate observations and influencers seeking engagement with increasingly outlandish claims. But America was merely the starting point. In India, the narrative mutated into something entirely different. WhatsApp, the primary communication platform for hundreds of millions, became a conduit for rumors that spread faster than fact-checkers could respond. Forwarded messages in Hindi described an alien spacecraft in disguise. Videos narrated with urgent voices asserted that the object was altering its course, and screenshots of fabricated news articles bore headlines designed to instill fear. One particularly viral forward claimed that world governments were already engaged in negotiations with whoever, or whatever, was aboard 3I Atlas. Another suggested clandestine military mobilizations. A third displayed an edited image purportedly from NASA, marked classified, depicting a geometric structure where the comet should have been. None of this was true, yet all of it propagated. Hindi-language YouTube channels experienced an explosion of content. Some offered earnest attempts at science communication, explaining the nature of interstellar objects. Others delved heavily into speculation, blending factual astronomical information with ancient astronaut theories and prophecies, blurring the lines between education and entertainment until they vanished completely. Brazil witnessed similar dynamics unfold on Telegram and Facebook. UFO enthusiast communities, already predisposed to find celestial anomalies, intensified their activities. Groups that had spent years analyzing unusual lights over the Amazon now had a tangible subject for their scrutiny. A genuine artifact from beyond our solar system, displaying characteristics that even learned individuals found perplexing. The landscape of conjecture in Brazil is remarkably fertile. It artfully merges ancestral folklore, the spiritual doctrines of Catholicism, and contemporary regulations concerning unidentified aerial phenomena, creating something that resists straightforward classification. 3I Atlas became a symbol for everyone, representing diverse meanings. It was heralded as an omen of the world's end. It was seen as a craft carrying enlightened beings destined to rescue humanity from its own failings. It was viewed as a weapon, a benevolent gift, or a challenging test. Online forums dedicated to discussion about the object experienced a surge in new participants. Live broadcasts examining the celestial body continued for extended durations. The presenters would read excerpts from scientific analyses, only to immediately transition into speculative theories that far surpass the scope of the original research. The comment sections transformed into virtual gathering places where thousands convened to share their anxieties and hypotheses in equal measure. The United Kingdom, with its established history of documented crop circle formations and investigations into UFO sightings, approached the phenomenon of 3I Atlas with a blend of cautious doubt and keen interest. British newspapers featured headlines that delicately balanced sensationalism with plausible deniability. Phrases like, "massive comet could be alien technology," appeared. The scientists whose statements were cited were typically quoted out of their intended context, yet these headlines achieved their intended impact. Russia, as anticipated, interpreted the entire situation through a geopolitical lens. State-controlled media briefly acknowledged the object, consistently highlighting the perceived indecision and confusion within American circles. Some commentators proposed that Western nations were fabricating a crisis to justify increased defense expenditure. Others subtly suggested that the United States government possessed knowledge beyond what it disclosed, possibly even hinting at clandestine programs having achieved contact. Russian online forums buzzed with detailed technical discussions. The depth of astronomical knowledge displayed was often remarkable, but alongside legitimate scientific discourse were theories linking 3I Atlas to various covert space initiatives, recovered extraterrestrial technology, and long-standing conspiracies dating back to the Soviet era. Then occurred the incident involving Michio Kaku. A digital image began circulating, purportedly showing the renowned theoretical physicist in a televised interview. Accompanying text claimed he had stated that 3I Atlas was en route to perform a reconnaissance mission, potentially with hostile intentions. The caption declared, "It might be an alien probe sent to Earth." The visual component of the image was authentic, but its context was entirely fabricated. Forensic analysis traced the screenshot back to a broadcast on Nation News from February 20th, 2025. This was months before 3I Atlas was even identified. Kaku had been discussing an entirely separate subject, most likely an asteroid impact scenario. Someone had appropriated his likeness, appended fabricated text, and disseminated it widely. The authenticity of the claim was irrelevant. The post garnered more than 290,000 views before social media platforms began to label it. By that point, it had been captured as a screenshot and reshared numerous times, with each subsequent iteration becoming increasingly difficult to trace back to its origin. The account responsible for the initial post, identified as Lord Bebo, never issued a retraction. The damage was already inflicted. Thousands of individuals now believe that a respected physicist had corroborated the notion that 3I Atlas represented hostile extraterrestrial technology. NASA attempted to issue a clarification. Their official solar system account posted on September 30th, stating, "Comet 3I Atlas poses no threat to Earth. It will remain hundreds of millions of kilometers away from our planet. This is a natural interstellar object, extremely rare and scientifically valuable, but not dangerous." The response was swift and met with skepticism. If it posed no danger, why the reported shutdowns? If it was not a threat, why the silence? If it was a natural phenomenon, how could the presence of nickel without iron be explained? NASA did not pursue further engagement. Their statement remained isolated, a solitary tweet confronting a deluge of speculation. Al Jazeera's fact-checking division, SANAD, published a comprehensive investigation. They confirmed the reality of 3I Atlas, identifying its discovery by the Atlas telescope on July 1, 2025. They verified that it posed no danger, with its closest approach to Earth projected to be approximately 270 million kilometers. They debunked the purported Kaku statements, claims of military mobilization, and rumors of clandestine negotiations. Their fact-check represented sound journalistic practice, yet it likely influenced very few opinions. This is because, concurrently with SANAD's investigation, Avi Loeb was addressing delegates at the United Nations. Not in an official capacity within the General Assembly, but through private conversations with representatives, in circulated documents for policy advisors, and in discreet meetings where the term existential was used without a hint of hyperbole. He articulated his black swan event theory. This concept posits that events with a low probability of occurrence but a high impact necessitate preparedness, particularly when they seem improbable. A black swan is defined as an event that appears impossible until it transpires, after which it seems self-evident in retrospect. Initially conceptualized by Nassim Nicholas Taleb to elucidate financial market collapses, Loeb applied this framework to the prospect of interstellar visitors. Our presumption is that all such phenomena are natural because we have only encountered natural occurrences. However, what transpires when this fundamental assumption is invalidated? The hashtag The Harbinger began to gain traction, not on mainstream social media platforms, but within specialized communities meticulously tracking 3I Atlas. This term originated from ancient texts and prophecies that described celestial messengers, heralds of momentous change, divine judgment, or profound transformation. Some individuals embraced its literal interpretation, mapping end times theology onto an interstellar object exhibiting inexplicable characteristics. Others adopted it metaphorically, viewing it as a precursor to a new era of space exploration or a catalyst for humanity's realization of a universe far more populated than previously conceived. Amidst this atmosphere of alarm, conjecture, and far-fetched theories, one voice consistently surfaced in public discourse. Stephen Burns, the cosmologist previously mentioned by Moneypenny, became the subject of claims suggesting his belief that 3I Atlas was sentient, possessed consciousness, and was already engaged in communication with both humanity and other planets. No verifiable source could be found for Burns's alleged pronouncements, whether in published papers or interviews. Only second-hand accounts and enigmatic social media posts were available. Nevertheless, the idea resonated because it seemed to align perfectly with the unfolding events. The observed anomalies, the prevailing silence, and the pervasive sense that something significant was occurring just beyond our capacity for clear perception. Chapter 7. December's Determination. In the early days of December 2025, 3I Atlas would re-emerge from behind the sun, akin to a swimmer surfacing after a profound dive. Astronomers would locate it within the constellation Virgo, appearing on the eastern horizon in the pre-dawn sky. Its magnitude, estimated at 12 or 13, would render it too dim for amateur telescopes but well within the range of professional observatories, and all eyes would be on the numerical data. Orbital mechanics stands as one of humanity's most precise scientific disciplines. Newtonian principles, refined by Einstein's theory of relativity, enable us to predict an object's position years in advance with remarkable accuracy, down to the kilometer. We can factor in gravitational influences from planets, the outward pressure exerted by solar radiation, and even the subtle effects of outgassing as comets release material. When 3I Atlas reappears, its precise location will reveal a crucial narrative. If its position precisely matches predictions derived from purely gravitational calculations, allowing for expected deviations due to outgassing, then we can reasonably infer that no extraordinary events occurred during its passage behind the Sun. It will have completed its perihelion, withstood the intense heat, and continued on its preordained trajectory into the outer reaches of the solar system, eventually returning to interstellar space. However, if its position deviates significantly, if its trajectory exhibits changes unexplainable by known physical forces, then every scientific paper written about this object will necessitate a supplemental addendum. Every established assumption will be challenged, as celestial bodies do not spontaneously alter their course. Something must instigate such a shift. The Vera C. Rubin Observatory is poised to play a pivotal role in the subsequent developments. This observatory, which only recently commenced full operations, represents a paradigm shift in our methods of celestial surveying. Previous asteroid detection programs identified approximately 20,000 new objects annually. In its initial 10 hours of operation, the Rubin Observatory discovered 2,114 asteroids. 10 hours, 2,000 asteroids. The implications are profound. As the Rubin Observatory redirects its focus to the detection of interstellar objects, what was a trickle will transform into an overwhelming influx. Scientists estimate that we could soon be identifying dozens of interstellar visitors each year, rather than one every few years. Each of these discoveries will be analyzed with the lessons learned from 3I Atlas fresh in our minds. We will know precisely what to scrutinize: the chemical signatures, the polarization characteristics, and the trajectory alignments. Should 3I Atlas prove to be genuinely anomalous, we will have other objects for comparative study. If it is the progenitor of a new class of celestial bodies, the Rubin Observatory will undoubtedly uncover its counterparts. Yet, December promises more than just insights into orbital mechanics and future observational campaigns. It signifies the culmination of questions that have been accumulating since July. What exactly did the Mars orbiters observe? By December, the governmental shutdown will have long since concluded. NASA will be operating at full capacity. The high-resolution images captured on October 3rd will have undergone processing, analysis, and either been archived or prepared for public release. These images, taken when 3I Atlas was a mere 29 million kilometers from the cameras, possess the potential to resolve features on the nucleus, provided the surrounding coma was not excessively dense. A 5-kilometer wide object at such a proximity should exhibit discernible structure. Not intricate detail, but fundamental morphology. Is its shape spherical, elongated, or irregular? Are there variations in brightness that might indicate the presence of different surface materials? Does it resemble other comet nuclei we have photographed, or does it present as something entirely novel? The fact that these images have not been made public raises persistent questions that will not simply dissipate with the turning of the calendar page to December. Scientific data is typically disseminated as rapidly as possible. The competitive drive to be the first to announce new findings is intense. The observation that multiple space agencies documented 3I Atlas near Mars, and yet none have released detailed imagery, suggests either an extraordinary level of coordinated silence, which seems improbable, or that the observed phenomena necessitate careful deliberation before public disclosure. December will compel a confrontation with this reticence. Either the images will surface, confirming it as merely an unusual comet, or the absence of these images will serve as its own form of answer. Radio astronomers will also be attentive. The connection to the WOW signal is either coincidental or it is not. If 3i Atlas was indeed the source in 1977, and if it retains the capability to transmit, then December offers another opportunity for detection. Numerous radio telescopes have been diligently monitoring the region where 3i Atlas is expected to be. This surveillance is being conducted not with the fanfare typical of SETI campaigns, but with steady, patient observation. Any detected signal, any pulse, any pattern within the radio frequencies that correlates with the object's position would be revolutionary. The hydrogen line at 1420 MHz is the specific frequency to monitor. It was at this frequency that the WOW signal was detected. It is the frequency that any civilization attempting to communicate across the cosmos would likely utilize, as hydrogen is the most abundant element in the universe, and its spectral line serves as a universal constant. If 3i Atlas has a message to convey, it is highly probable that it will do so at this frequency. December 19th marks the moment of its closest approach to Earth, occurring at 1.8 astronomical units, approximately 270 million kilometers. For context, this distance is roughly 1.5 times the separation between Earth and the Sun. While not close by any standard that implies a safety risk, it is sufficiently near for parallax measurements to become significant. Parallax refers to the apparent displacement of an object's position when viewed from different vantage points. As Earth traverses its orbit around the Sun, our observational angle relative to 3i Atlas undergoes a subtle alteration. By measuring this shift with exceptional precision, we can determine the object's exact distance and velocity through triangulation. Any deviation from the anticipated values will be immediately apparent. Observatories worldwide will coordinate their efforts, encompassing both the northern and southern hemispheres in multiple longitudes, to provide continuous 24-hour coverage. Amateur astronomers will contribute data alongside their professional counterparts. This undertaking will represent one of the most meticulously documented observations of any solar system object in recorded history. And somewhere within this vast dataset, we will find either confirmation or contradiction. Confirmation that this object, despite all appearances, is indeed a natural entity from interstellar space, exhibiting rare but explicable characteristics, an envoy from another planetary system. Its strangeness stems from its formation under conditions distinct from those of our solar system's comets, yet ultimately governed by the same fundamental physics. Or contradiction, evidence of something within its trajectory, its chemical composition, or its behavior that cannot be reconciled with natural origins, a data point that shatters existing models, and proof that compels us to confront what we have been deliberately avoiding. By the end of December, 3i Atlas will begin to diminish in brightness once more as it recedes from the Sun, entering the constellation Leo and heading back towards the orbital path of Jupiter, which it will traverse in March of 2026. Following that, it will venture into the outer solar system and ultimately into interstellar space. One way or another, December will provide us with answers. Not necessarily all of them, but enough to determine whether we are witnessing the most spectacular cometary display of our generation or the most profound reorientation of human understanding since our realization that Earth is not the cosmic center. The telescopes are prepared, the calculations are finalized, the world is watching. Now, we await the reappearance of 3i Atlas from behind the Sun to reveal its true nature. Chapter 8. The Scientific Realities. Allow me to delve deeper into the scientific intricacies that are keeping astronomers awake at night. I am referring not to conjecture or theoretical musings, but to the actual measurements that defy logical explanation, regardless of how many times the data is reanalyzed. Let us commence with the WOW signal. On August 15, 1977, the Big Ear radio telescope at Ohio State University was engaged in a routine search for extraterrestrial intelligence when it detected a phenomenon that defied conventional explanation. It was a narrow-band signal at a frequency of 1420.4 MHz, precisely the frequency one would anticipate for an artificial transmission. The signal persisted for 72 seconds, the exact duration it would take for the telescope's beam to sweep across a stationary source as the Earth rotated. The signal's intensity was remarkable, registering 30 times stronger than the ambient background noise. On the printout, the intensity values escalated from the typical readings of 1 and 2, climbing through 5 and 6, and peaking at a U, the highest symbol the system could produce before exhausting its alphanumeric characters. Astronomer Jerry Eman, Observing these escalating values, inscribed a single word in the margin. Wow. Subsequent attempts to locate the signal were fruitless. For years, even decades, the Big Ear telescope was directed at that precise patch of sky numerous times. Other observatories joined the investigation. Nothing. The signal never recurred. Eventually, it became astronomy's most enigmatic mystery. Evidence of nothing. Proof of nothing. Yet impossible to forget. Now, let us trace 3I Atlas backward through space. We must account for its velocity of 60 kilometers per second and map its trajectory through the galaxy. In 1977, it would have been situated approximately 600 astronomical units from Earth, 600 times the distance from Earth to the Sun, a staggering 90 billion kilometers. To generate a signal as potent as that detected by Big Ear at such a vast distance would necessitate a transmitter outputting between half a gigawatt and 2 gigawatts of power. This is not the capacity of a battery, nor even a conventional generator. It is the power output of a nuclear reactor. This sustained energy, precisely focused into a beam narrow enough to traverse 90 billion kilometers and still register 30 times above background noise, is truly astounding. Could a comet achieve such a feat? Not within the framework of our current understanding of physics. Comets do not generate gigawatts of power. They do not emit coherent radio signals. They do not broadcast at the exact frequency that coincidentally serves as the universal marker for technological civilizations seeking to communicate. However, an object intentionally designed to be discovered, an object that needed to announce its presence before entering the inner solar system, would indeed broadcast in precisely this manner. One powerful pulse, sufficient to be unmistakable, followed by silence, as revealing one's position prematurely would be unwise. Now, consider the chemical composition data from the Very Large Telescope, indicating the presence of nickel devoid of iron. In their natural state, these two elements are intrinsically linked from their inception. When a massive star collapses in a supernova, it forges heavy elements within its explosive core. Nickel-56 decays into iron-56. They are synthesized through the same nuclear processes, bound within the same mineral structures, and released into space as an inseparable pair. Every meteorite, asteroid, and comet ever subjected to analysis has demonstrated their co-occurrence. While the ratio may vary slightly depending on the environmental conditions, both elements are invariably present. 2I Borisov, originating from interstellar space much like 3I Atlas, exhibited normal nickel to iron ratios. Comets within our solar system also display normal ratios. There is no known natural process, at the temperatures experienced by 3I Atlas, capable of separating these elements. However, refinement, smelting, and chemical processing, the industrial production of nickel alloys, often involves the removal of iron impurities. We perform this process on Earth daily, producing high-purity nickel for electronics, specialized alloys, and applications where iron would be detrimental. This process leaves a distinct signature: nickel without iron. The scientists who published this data from the VLT exhaustively explored every conceivable natural explanation. They considered unusual chemical pathways within the ice, the possibility of exotic minerals formed under previously unobserved conditions, or even dust grain physics that we do not yet fully comprehend. Every hypothesis encountered the same insurmountable obstacle. The temperature was too low, the environment unsuitable, and such an occurrence should not be possible. Furthermore, this is not a static phenomenon. The production of nickel intensifies as the object's proximity to the sun decreases, exhibiting an exponential increase governed by a power law of approximately 9. This implies that with every 10% reduction in distance from the sun, the nickel output escalates significantly. This is not indicative of random outgassing. It is a process that accelerates with increasing solar energy, akin to something powering up. Then there is the tail that points in the incorrect direction, defying one of the most fundamental and reliable principles in planetary science. Solar radiation pressure is a relentless force. When photons from the sun impact dust particles, they impart momentum. Although individually minute, this continuous push, over time, overcomes the weak gravitational pull of a comet and propels dust particles away from the sun. Every comet ever photographed exhibits this phenomenon. The tail invariably points away from the sun. Invariably, except for 3I Atlas, which displays scattered light extending twice as far towards the sun as away from it. The Hubble image is unambiguous. Enhancing the data further clarifies this anomaly. There is demonstrably more material directed sunward than anti-sunward. Avi Loeb and Eric Kito published a model proposing that this could occur if the object sheds large ice fragments from its sun-facing hemisphere, and if these fragments persist longer due to their size, thereby creating an extended snow line in the solar direction. The physics of this scenario are theoretically sound, involving ice fragments of specific dimensions ejected at precise velocities under particular solar heating conditions. However, these conditions are exceptionally narrow. It requires preferential ejection from the day side. The fragments must be sufficiently large to resist radiation pressure yet small enough to effectively scatter visible light, and the evaporation rate must be precisely calibrated for the fragments to survive long enough to create the observed distribution. While technically possible, it is exceedingly improbable, comparable to flipping a coin 50 times and achieving heads on every occasion. The laws of physics do not prohibit it, but the statistical likelihood raises questions about the impartiality of the coin. This pattern is consistent across all anomalies. Each anomaly possesses a natural explanation that holds true, provided one is willing to accept that 3I Atlas is configured in unique ways never before observed in any other comet. Its mass can be accounted for by assuming an uncommonly high density. Its trajectory can be explained by a statistically rare fluke. Its chemical composition can be attributed to exotic processes occurring under unknown conditions. Its polarization characteristics can be reconciled by assuming a dust grain distribution unlike any catalog. While each explanation is plausible in isolation, they are not isolated phenomena. They accumulate 7 distinct anomalies, each demanding its own specific justification, all occurring within the same celestial object. At what juncture does the most straightforward explanation cease to be merely natural and begin to suggest deliberate design? That is the central puzzle perplexing experts as 3 celestial wanderers approach while obscured by the sun. By the first day of October 2025, an object traversed Earth's vicinity within 250 miles. At that very altitude, individuals inhabit and labor aboard the International Space Station, and commercial satellites follow meticulously mapped trajectories. However, this particular entity, designated asteroid 2025 TF, went entirely unnoticed. Our detection occurred a mere 6 hours after it had already streaked past us at an astonishing speed exceeding 13,000 miles per hour, just above the South Pole. Contemplate that for a moment. A celestial fragment, akin to the size of a small automobile, moving at a velocity swifter than any projectile, passed through the precise atmospheric corridor where humankind conducts its most sophisticated endeavors, completely undetected. Meanwhile, on the Martian surface, our exploratory vehicles have unearthed what researchers are acclaiming as the most unambiguous indication of primordial life ever discovered. Intricate patterns, preserved as if by time itself, that could potentially confirm our solitary existence is a misconception. Congressional inquiries have recently brought to light visual evidence of a military projectile impacting an unidentified object off the coast of Yemen. Intriguingly, the object did not detonate but continued its unimpeded flight. The sun is currently entering a phase characterized by physicists as a final, intense emission, which could illuminate our atmosphere with auroral displays far surpassing anything observed in recent decades. 3 comets are presently hurtling towards us, their coloration shifting to green as they draw nearer, and one is anticipated to become visible to the naked eye within weeks. NASA has undergone a significant reduction in its workforce, with 15,000 employees laid off, all while engaged in a race with China to reach the moon. Simultaneously, a private enterprise is on the verge of launching the most potent rocket ever constructed, possibly for its ultimate trial run before a comprehensive overhaul. This is not a work of imagination. This is the reality of October 2025. If you are prepared to delve into the remarkable events unfolding directly above us, please engage the like button and subscribe, as we are about to dedicate the next 2 hours to dissecting the most extraordinary astronomical news of our era. Share in the comments your location, the current time there, and which of these narratives astonishes you the most. Furthermore, if you wish to contribute to the expansion of our community, please disseminate this information across X, Facebook, Reddit, or your preferred messaging platform. Your consistent support is greatly appreciated. Let us commence with the celestial body that eluded our protective measures. Chapter 1. A Close Call. The asteroid that took humanity by surprise. We have allocated vast sums of money toward the development of a planetary defense network. Telescopes strategically positioned across Earth continuously scrutinize the nocturnal sky, meticulously cataloging every celestial body in motion, calculating their trajectories, and ensuring that no hazardous entity approaches without prior notification. This system functions with remarkable efficacy for larger asteroids, those of a magnitude capable of eradicating cities or even entire civilizations. We monitor these objects months or even years in advance. However, on the first day of October 2025, our entire detection infrastructure failed to register an object until it had already passed into our observational wake. Asteroid 2025 TF possesses a diameter estimated to be between 1.2 and 2.7 meters. While not a world-ending threat, it is comparable in size to a compact automobile. It was traveling at a speed of 20.9 kilometers per second, which translates to nearly 13,000 miles per hour, sufficient velocity to traverse the continental United States in under 4 minutes. At its nearest point of approach, shortly after midnight UTC on October 1st, this rocky mass passed at an altitude of 419 kilometers above Antarctica. To provide context, the International Space Station orbits at approximately 420 kilometers. This asteroid navigated the same spatial region where astronauts reside. The Catalina Sky Survey in Arizona identified it at 2:35 in the morning Eastern Time on October 1st, utilizing the Bok telescope at the Kitt Peak National Observatory. Yet, here lies the disconcerting aspect that should elicit concern. That detection occurred 6 hours and 36 minutes after the asteroid's closest passage. We observed its departure, not its approach. Currently, asteroid 2025 TF ranks as the second closest asteroid flyby ever documented. The previous record holder, asteroid 2020 VT4, passed even nearer in November 2020, coming within 370 kilometers of Earth's surface. However, that object was also identified retrospectively. There appears to be a recurring pattern, and it is not an encouraging one. The challenge does not stem from negligence. The astronomers and engineers managing these detection systems are among the foremost professionals globally. The fundamental issue lies with the principles of physics and the allocation of resources. Small asteroids like 2025 TF are exceptionally challenging to detect. They are dark, move at high speeds, and reflect minimal sunlight. Our telescope networks are engineered for the identification of larger bodies, those exceeding 150 meters in diameter that would inflict widespread destruction. These are tracked with meticulous diligence. However, objects in the range of 1 to 10 meters, numbering in the millions, remain virtually invisible until they are almost upon us. This is where the situation becomes more intriguing. Once asteroid 2025 TF was finally observed, scientists had to work backward to ascertain its orbital path. They determined it follows an elongated trajectory around the Sun, with a semi-major axis of 1.62 astronomical units. Its orbit brings it as close as 0.676 astronomical units to the Sun at its closest point and as far as 2.56 astronomical units at its farthest. The orbital period is approximately 2.06 years, and the inclination of its orbit relative to the ecliptic plane, the flat disk where most planets orbit, is about 9.1 degrees. Nevertheless, all these figures are subject to substantial uncertainty. The orbit is described by astronomers as poorly constrained, carrying a condition code of 7. This signifies that the calculations are derived from an observational arc spanning only 1 day, a snapshot so brief that predicting the asteroid's future position is more speculative than scientifically definitive. Additional observations are imperative to refine its trajectory and assess any potential risks during subsequent encounters with Earth. Consider the implications. An object passed closer to Earth than some of our orbiting satellites, and we possess only a vague understanding of its origin or its future path. It could reappear. It might be on a collision course with Earth decades from now, or it may never approach us again. We simply do not possess this knowledge. The unsettling reality is that asteroids of this size impact Earth more frequently than most individuals comprehend. The Tunguska event in 1908, which flattened approximately 830 square miles of Siberian forest, was likely caused by an object measuring between 30 and 50 meters across. While larger than 2025 TF, the difference is not substantial. Had asteroid 2025 TF been on a trajectory to impact rather than merely fly by, it would have detonated in the atmosphere with an explosive force equivalent to several kilotons of TNT. This would not be sufficient to end civilization, but would undoubtedly possess the capacity to devastate a city if it were to detonate overhead. And we would have remained unaware of its approach until it was too late. Scientists are characterizing this incident as a stark warning. The near miss has re-energized discussions regarding the enhancement of our detection capabilities for smaller near-Earth objects. Because if there is one certainty derived from this encounter, it is that our cosmic vicinity is considerably more active and perilous than our existing systems can fully monitor. The pertinent question is not whether another asteroid will surprise us, but rather when, and whether we will be fortunate enough for it to miss us once more. However, while our attention is focused on celestial bodies passing Earth, something far more significant has been transpiring on the surface of Mars. Something that might provide an answer to one of humanity's most enduring questions. Chapter 2. A Martian Breakthrough. The Smoking Gun of Ancient Life. For more than a year, a rock on Mars has occupied the thoughts of scientists. Not due to its size or composition, but because of the inscriptions upon its surface. Patterns that, if found on Earth, would be unmistakable indicators of life. On September 10, 2025, NASA issued a statement that sent reverberations throughout the scientific community and beyond. The Perseverance rover's discovery of potential biosignatures within a sample designated Sapphire Canyon has withstood the most rigorous scientific examination imaginable, including peer review and subsequent publication in the esteemed journal Nature. Acting NASA Administrator Shaw Duffy succinctly stated, "This very well could be the clearest sign of life that we've ever found on Mars." Let us rewind to July 24, 2024, when Perseverance drilled into an arrowhead-shaped rock, informally named Chayeva Falls, located within Mars' Jezero crater. The rover's instruments immediately detected something intriguing. The rock's surface was adorned with what scientists began referring to as leopard spots, small, circular formations characterized by lighter central areas encircled by darker rims. These were not merely decorative patterns. They represented chemical signatures that, on Earth, are frequently produced by microbes metabolizing organic matter and excreting specific minerals as byproducts. These spots contain vivianite and grayite, two minerals that form in environments with low temperatures and abundant water. Vivianite is a hydrated iron phosphate often found in proximity to decaying organic material and sediments. Grayite is an iron sulfide that certain microbial life forms generate as a metabolic waste product. The co-occurrence of these minerals, collocated with organic carbon, creates what geologists term a compelling potential biosignature. However, the narrative intensifies further. Chayeva Falls is situated within a geological formation known as Bright Angel, located along the periphery of Nuret Valles, an ancient river valley that once conveyed water into Jezero crater over 3 billion years ago. This valley measures approximately a quarter mile in width, indicating sustained and powerful water flow over extended periods. The mudstones and layered sediments within Bright Angel narrate a tale of a dynamic environment where rapidly flowing rivers alternated with periods of tranquil, still water. Precisely the kind of setting where microbial life thrives on Earth. This discovery was particularly surprising as Bright Angel represents some of the most recent sedimentary rocks investigated by the Perseverance mission. Previous hypotheses posited that evidence of ancient life would be confined to older rock formations, remnants of Mars's earliest, most habitable epoch. However, the presence of these features in comparatively younger rocks suggests that Mars may have remained habitable for a longer duration than initially believed, or that life persisted later into the planet's history than we had envisioned. Now, before we become overly enthusiastic, it is crucial to clarify the meaning of a potential biosignature. This is not conclusive proof of life, but rather evidence requiring further investigation. As mission scientist Katie Stack Morgan emphasized, astrobiological claims, particularly those pertaining to the potential discovery of past extraterrestrial life, necessitate extraordinary evidence. The peer review process that led to the publication in Nature was intentionally stringent, with external scientists dedicating an entire year to meticulously scrutinizing the data and analysis presented by the Mars 2020 team. They sought alternative explanations, non-biological processes that could account for the observed patterns. While some possibilities were identified, none adequately explained the evidence as comprehensively as the biological hypothesis. This is what imbues this discovery with such profound significance. The Perseverance rover employed two sophisticated instruments to analyze Chaiva Falls. SHERLOC, which stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, detected a robust spectral signature known as the GAND, indicative of organic carbon. PIXL, the planetary instrument for X-ray lithochemistry, precisely mapped the distribution of chemical elements across the rock's surface with remarkable accuracy. Collectively, these instruments revealed that the organic matter and the redox-sensitive minerals were not merely present. They were collocated within the same minute spots, clustered together in a manner strongly suggesting a causal relationship. On Earth, this type of spatial association is commonplace in microbial environments. Bacteria consume organic compounds and excrete minerals as waste. These minerals precipitate directly where the microbes are situated, forming distinctive patterns. The leopard spots observed on Chaiva Falls bear a striking resemblance to features found in ancient terrestrial rocks where microbial activity is known to have occurred. However, there is a significant caveat. To definitively confirm whether these features originate from a biological source, scientists must transport the Sapphire Canyon sample back to Earth. Here, it can be analyzed using instruments far more advanced than any currently deployable on Mars. Terrestrial laboratories possess the capability to perform isotopic analysis, examine the molecular structure of organic compounds, and conduct experiments that are simply beyond the scope of a rover's limited toolkit. This is where the political machinations enter the equation. The Mars Sample Return Mission, a collaborative initiative between NASA and the European Space Agency, was conceived precisely for this purpose: to retrieve the samples meticulously collected by Perseverance and deliver them to Earth-based laboratories. However, the mission has been beset by escalating costs and schedule delays. President Trump's proposed budget for 2026 includes the complete cancellation of the current Mars Sample Return Program, eliminating its funding entirely. During the press conference in September announcing the findings from Chaiva Falls, Duffy indicated this was not an abandonment of the objective but rather a strategic shift towards identifying a more economical and expedited alternative. Concurrently, China has announced its own ambitions for a Mars Sample Return mission, with a potential launch as early as 2028. If the United States fails to retrieve Perseverance's samples, China may well be the first to bring Martian material back to Earth, and they could be the entity to definitively answer the question of whether life ever existed on Mars. The geopolitical ramifications are immense. For the present, the Sapphire Canyon sample remains securely encased within a sealed tube on the Martian surface, awaiting its destiny. It holds what could be the most significant scientific discovery in human history: preserved evidence that has the potential to fundamentally alter our understanding of life's place in the cosmos. Yet, while that sample waits, another development has been unfolding much closer to home, compelling governments to confront questions they might prefer to evade. Chapter 3. The UFO Mystery Deepens. Congress unveils shocking footage. On September 9, 2025, Congressman Eric Burleson of Missouri addressed a House Oversight Committee hearing, presenting footage that had never before been seen by the public. The video, dated October 30, 2024, depicts a luminous, spherical object moving against a dark backdrop. Subsequently, with startling abruptness, a Hellfire missile enters the frame. The missile strikes the object directly. What transpires next defies all conventional understanding of missile behavior. The object does not detonate, nor does it fracture, nor does it appear to decelerate. The missile seems to ricochet off, continuing its trajectory independently, while the orb proceeds unimpeded. "That's the Hellfire missile smacking into that UFO and just bouncing right off," Burleson remarked, commenting on the visual evidence. And it kept going. He paused, then posed the question that has since echoed through defense circles. "I'm not going to speculate what it is, but the question is, why are we being blocked from this information consistently?" The footage was captured by an MQ-9 Reaper drone operating in the vicinity of Yemen. At the time, the waters near Yemen were an active theater of conflict, with U.S. Navy vessels and aircraft safeguarding commercial shipping lanes from missile and drone attacks launched by Houthi militants. American forces were routinely intercepting threats in that region. However, this object, whatever its nature, did not behave like a drone or a missile, and it certainly did not respond to a Hellfire strike in a manner consistent with any known aircraft. When questioned about the authentication of the video and the provision of details regarding its origin and time of capture, the Department of Defense offered no comment. A defense official informed reporters, "We do not have anything to provide on this." A DoD spokesperson added, "I have nothing for you." This stonewalling only served to deepen the enigma. However, the Yemen video was not the sole revelation during the hearing. Multiple military veterans testified under oath about their personal encounters with unidentified anomalous phenomena, the government's current designation for what were formerly referred to as UFOs. Air Force veteran Dylan Boland described an incident in 2012 when he stepped outside for a cigarette break during an overnight shift at Langley Air Force Base in Virginia. A triangular aircraft hovered above him for several minutes, remaining silent and stationary. Then, according to Boland, the object rapidly ascended to the altitude of a commercial jet and departed the area at high speed. Boland reported the incident through official channels. He was interviewed by AARO, the Pentagon's All-Domain Anomaly Resolution Office, in 2023. However, instead of being taken seriously, he claims his report was dismissed. Worse still, he alleges he faced workplace retaliation, manipulation of his security clearance, and blacklisting from employment within federal intelligence agencies. His testimony painted a picture of a system that not only fails to investigate UAP encounters but actively penalizes those who come forward. The hearing was not solely focused on individual sightings. It addressed the critical issue of transparency, or rather, the lack thereof. Representative Anna Paulina Luna, who chairs the task force, commenced the session by stating, "For too long, the issue of unidentified anomalous phenomena, commonly known as UAPs, has been shrouded in secrecy, stigma, and in some cases, outright dismissal. This is about national security, government accountability, and the American people's right to the truth." What distinguishes this juncture from decades of UFO speculation is the caliber of the witnesses. They are not fringe conspiracy theorists, but military personnel with unblemished service records, security clearances, and first-hand operational experience. The footage is not grainy, cell phone video captured by a civilian. It is sensor data acquired from advanced military platforms during active operations in contested airspace. And the resistance to disclosure is not emanating from clandestine groups but from official Pentagon offices purportedly tasked with investigating these incidents. AARO maintains that it possesses no verifiable evidence of extraterrestrial activity or technology. The agency asserts its utilization of a rigorous scientific framework and a data-driven approach to better comprehend UAPs. However, critics point out that many of the most compelling cases, including the incident in Yemen, tend to be explained away using logic that does not entirely align. Consider the notorious Go Fast video from 2015, which depicted a fast-moving object appearing to traverse the sky at high velocity above ocean waves off the coast of California. AARO analysts ultimately concluded that it was an optical illusion involving a weather balloon, attributing the apparent high speed to parallax and the angle from which the Navy F-18's camera viewed the object. Yet, pilots who witnessed these objects directly, not merely through sensor readings, maintain that the official explanations do not correlate with their experiences. Some analysts have suggested that the Yemen orb might also have been a balloon drifting at high altitudes, reflecting sunlight. The theory posits that its apparent rapid movement was due to parallax as the drone's camera tracked it. And the missile, perhaps it simply missed its intended target, and the angle of the footage created the illusion of a direct impact. However, former senior intelligence official Luis Elizondo, who testified at the hearing, vehemently refuted that explanation. "We've never seen a Hellfire missile hit a target and bounce off," he stated. "When a Hellfire makes a kinetic strike on something solid, there's usually not much left of whatever it is it's hitting. It's very, very destructive." So, what is the prevailing conclusion? Either the U.S. military encountered an entity possessing technology far beyond our current capabilities, technology capable of withstanding a direct missile strike and continuing to function, or there exists a conventional explanation that officials are deliberately withholding from public dissemination for reasons that can only be surmised. Neither scenario offers much comfort, and this is not an isolated occurrence. The National UFO Reporting Center recorded over 2,000 UAP sightings in the initial 6 months of 2025 alone, representing a substantial increase compared to previous years. The Pentagon has documented over 750 new accounts between May of 2023 and June of 2024. Whatever is transpiring in our skies is occurring with increasing regularity, and a greater number of individuals are paying heed. While global administrations endeavor to comprehend atmospheric phenomena they cannot explain, a far more predictable, yet equally striking event has been unfolding overhead, propelled by the very star that sustains all life on our planet. Chapter 4: Solar Fury, the Sun's Final Outburst. In October of 2024, scientific professionals revealed information that should have commanded widespread attention, but, for reasons unknown, was overshadowed by the daily news cycle. The Sun has attained solar maximum, the zenith of its 11-year activity cycle. To the general populace, this may sound like an abstract astronomical concept, relevant to researchers but disconnected from daily life. However, the current state of our star is anything but theoretical. The most intense repercussions may still be on the horizon. Here's a crucial detail often omitted about solar maximum. The peak of solar activity does not signify the conclusion of dramatic events. Rather, it indicates our entry into a period that could generate more geomagnetic disturbances and more breathtaking auroras than the maximum itself. Envision a firework that burns with its most intense radiance not at ignition, but during its final explosive moments before extinguishing. The Sun is poised to deliver its parting gasp, a phenomenon that could illuminate skies globally for the subsequent 2 years. Pali, a solar physicist at the Norwegian Space Agency, articulated this clearly. Aurora enthusiasts have reason to celebrate, as peak auroral activity typically follows solar maximum by a few years, suggesting several more years of heightened aurora displays. Let that sink in. We are not at the show's conclusion, but rather approaching its grand finale. To grasp why, we must first understand the drivers of auroras. During solar maximum, the Sun's surface erupts, with sunspots, zones of intense magnetic energy where the star's magnetic field lines become contorted and strained. When these lines rupture and reconfigure, they unleash immense energy as solar flares and coronal mass ejections. A single coronal mass ejection can propel billions of tons of plasma into space at speeds exceeding 1 million miles per hour. When this plasma collides with Earth's magnetic field, it instigates geomagnetic storms that channel charged particles towards the poles. There, these particles interact with atmospheric atoms, creating the ethereal curtains of light we recognize as auroras. Yet, the narrative becomes more intriguing. Following solar maximum, the frequency of explosive flares and coronal mass ejections begins to diminish. One might anticipate a corresponding decrease in auroras, but this assumption would be incorrect. During the waning phase of the solar cycle, a different phenomenon emerges: the formation of persistent coronal holes. These are dark regions in the Sun's atmosphere where magnetic field lines open into space, allowing continuous streams of high-velocity solar wind to escape. These swift solar wind streams can endure for weeks or even months, subjecting Earth's magnetic field to sustained pressure that triggers geomagnetic storms as potent as those caused by coronal mass ejections. Solar physicist Chaskov explained it thusly: during the declining phase, we experience an increase in geomagnetic storms. While the Sun's eruptive activity may slightly subside after the solar maximum, the continued formation of coronal holes and the occurrence of numerous eruptions collectively lead to more frequent and sometimes more intense auroral displays. We are already witnessing this unfold. In early October of 2025, Earth endured 5 consecutive days of geomagnetic activity, fueled by a fast solar wind stream originating from a coronal hole. Solar wind velocities reached 768 kilometers per second before gradually decreasing to 608 kilometers per second. Even at these reduced speeds, the solar wind was potent enough to provoke isolated G1, or minor, geomagnetic storm levels. Auroras illuminated northern latitudes, becoming visible as far south as New York on certain nights. Photographers in Iceland, Norway, Canada, and the northern United States captured breathtaking images of emerald, rose, and violet lights undulating across the heavens. This was merely a prelude. A minor coronal mass ejection, ejected by an M.5 class solar flare in early October, is anticipated to reach Earth around October 8th, potentially precipitating another wave of disturbances. Scientific projections suggest that the current solar cycle, Cycle 25, could sustain elevated levels of geomagnetic activity well into 2027 or beyond, driven by this confluence of lingering eruptions and enduring coronal holes. Furthermore, an additional factor, unrelated to the Sun itself, plays a role. Earth's orientation during the equinox season, which we are still experiencing in early October, renders our planet more susceptible to geomagnetic storms. At the equinoxes, the angle of Earth's magnetic field relative to the incoming solar wind creates conditions that permit greater penetration of particles into our defenses, leading to more robust auroral displays. It is akin to opening a door that is typically only partially ajar. The practical ramifications of this solar activity extend beyond visual splendor. Geomagnetic storms possess the capacity to disrupt radio communications, interfere with GPS systems, hasten the decay of satellite orbits, and, in extreme scenarios, jeopardize power grids. During the significant geomagnetic storm of March 1989, triggered by a powerful coronal mass ejection, the entire province of Quebec experienced a 9-hour power outage. Transformers overheated, circuit breakers tripped, and millions were plunged into darkness. That storm reached G5, or extreme, levels on the geomagnetic storm scale. The current storms have predominantly been G1 to G3, moderate in comparison, yet still sufficiently strong to present challenges for satellite operators and airline pilots traversing polar routes. Scientists employ the KP index, ranging from 0 to 9, to quantify geomagnetic activity. A KP of 5 or higher signifies storm conditions. During the initial week of October 2025, the KP index fluctuated between 3 and 5, with transient spikes into storm territory. Forecasters anticipate this trend will persist, characterized by frequent unsettled to active conditions punctuated by occasional more intense storms in the coming months. For those not managing satellites or power grids, the primary impact of this solar intensity is sheer beauty. Auroras are among Earth's most magnificent natural spectacles, and the next 2 years may offer some of the most remarkable viewing opportunities in decades. Individuals residing at high latitudes, north or south of 50 degrees, will have regular chances to witness these lights. Even those at mid-latitudes, as far south as approximately 40 degrees, may catch glimpses during more powerful storms. The sun's final gasp is transforming into a celestial light show for the ages. However, as the sun adorns our skies with brilliance, other cosmic visitors are approaching from the depths of space, bringing their own distinct spectacle. Chapter 5, Comet Chaos. 3 green visitors illuminate October skies. Something extraordinary is occurring in October of 2025. Look skyward on a clear night from the appropriate vantage point, and you may observe not 1, not 2, but 3 comets simultaneously visible. All of them possess a distinct green hue. Each was discovered only this year, and one of them may attain sufficient brightness to be discernible to the unaided eye. A rare gift in an era when most comets remain frustratingly faint. The principal performer in this celestial pageant is Comet C 2025A6, more commonly known as Comet Lemon. It derives its name from the Mount Lemmon Observatory in Arizona, where it was first detected on January 3, 2025. At the time of its discovery, its magnitude was 21.5, so dim that astronomers initially suspected it to be an asteroid. It was only upon subsequent observations revealing a distinct coma and a short tail that its true nature became apparent. For much of the year, Lemon remained an obscure object, tracked by professional astronomers but largely overlooked by the public. Initial predictions indicated it would peak around magnitude 9 near its perihelion in early November, bright enough for terrestrial telescopes but far from naked eye visibility. Then, an unexpected event transpired. In mid-August, after emerging from solar conjunction, a period when the comet was obscured by the sun's glare. Observers noted a significant increase in its brightness compared to predictions. By August 19th, its magnitude had surged to 11. A short, spiky tail became apparent, and the brightening continued unabated. By late September, Comet Lemon had reached a magnitude of 8 to 9, readily observable with binoculars and small telescopes. Astrophotographers began capturing striking images, not only of the luminous nucleus and surrounding coma but also of an extended ion tail streaming away from the sun, complete with intricate swirls and knots as the tail interacted with the solar wind. On September 30th, the comet had brightened to magnitude 6.6, boasting an ion tail spanning approximately 3 degrees across the sky, with a dust tail also becoming discernible. Current projections, updated almost daily as new observations become available, suggest Comet Lemon will achieve a magnitude of 4, potentially even 3, as it makes its closest approach to Earth on October 21st, at a distance of 56 million miles. This places it on the very threshold of naked eye visibility. From locations with dark skies, far from urban light pollution, individuals may indeed be able to discern it as a faint, hazy star. Furthermore, unlike many comets that reach their peak brightness when they are too close to the sun for safe observation, Lemon will be favorably positioned in the evening sky, approximately 42 degrees from the sun, visible in the west about an hour after sunset. The comet will continue to brighten after its closest approach as it journeys toward its perihelion, its nearest point to the sun, on November 8th. The most favorable viewing conditions are anticipated around Halloween and into early November, when Lemon will traverse the constellation Perseus. For observers in the northern hemisphere, this represents a once-in-a-lifetime opportunity. Comet Lemon follows an exceptionally elongated orbit and may not return for 1,350 years, if at all. But Lemon is not the sole celestial traveler. Comet C 2025 R2 Swan was discovered merely weeks ago, precisely one day before reaching its closest proximity to the sun. Its earlier detection was prevented by the sun's glare, which concealed it from ground-based telescopes. It was actually identified by sharp-eyed amateur astronomers Vladimir Bazuki and Michael Matiazzo in images acquired by the SWAN instrument aboard NASA's Solar and Heliospheric Observatory, a space-based telescope designed for solar observation, hence its designation. This comet will not significantly increase in brightness as it is now receding from the sun, but it will become easier to observe as it gains distance from the sun's glare from our perspective. On October 20th, it will achieve its closest approach to Earth at a distance of 24 million miles. Spectacular photographs have already captured its tail extending beyond the star Altair. This weekend, it will pass within 1 degree of Mars, presenting a stunning photographic opportunity for astrophotographers to frame both celestial bodies together. The third member of this cosmic trinity is Comet C 2025 K18 Atlas, named after the Asteroid Terrestrial Impact Last Alert System, a survey designed to detect near-Earth asteroids but also capable of identifying comets. K18 Atlas is fainter than the other two, but its brightness is increasing as it nears the sun. It will be most visible before dawn in the coming weeks for patient observers equipped with binoculars or small telescopes. The pervasive green hue of all three comets originates from diatomic carbon molecules, composed of two bonded carbon atoms. These molecules absorb sunlight and re-emit it at a wavelength perceived as green by the human eye. As comets approach the sun, solar radiation disassociates larger organic molecules within their icy cores, releasing diatomic carbon into the coma. The closer the comet, the greater the release of carbon, resulting in a more intense green glow. Intriguingly, a fourth green comet is currently observable, though it is considerably more challenging to detect. The Interstellar Visitor 3 Atlas, only the third comet ever documented from beyond our solar system, has recently transitioned from a crimson tint to an emerald shade. This transformation is attributed to its interaction with solar radiation in ways that scientists are still endeavoring to comprehend. However, that narrative will be revisited shortly. Comet Lemon has already surpassed all initial expectations, generating genuine enthusiasm among astronomers regarding its potential peak brightness. Nick James, director of the Comet section of the British Astronomical Association, informed spaceweather.com, "This comet is developing very nicely, and it is already an impressive object, well placed for observation in the morning sky. It is definitely worth getting up for. The inherent unpredictability is a significant factor contributing to the captivating nature of comets. Unlike planets or stars, which follow predictable trajectories and maintain consistent brightness, comets are erratic, sometimes disappointing, and occasionally spectacular. They can exhibit sudden brightenings, fragment unexpectedly, or fade into obscurity precisely when a grand display was anticipated. Predicting a comet's behavior is akin to forecasting the weather 6 months in advance. Educated guesses can be made based on physical principles and historical data, but nature always retains the prerogative to surprise. And surprises are precisely what we are witnessing in October of 2025. 3 green comets simultaneously streaking across our skies, one potentially visible to the naked eye. The sun ablaze with activity, auroras dancing at mid-latitudes, asteroids subtly evading our defenses, and on Mars, a rock adorned with patterns that might be fossilized remnants of ancient life. Yet, amidst this natural cosmic drama, a single company is preparing to launch the most formidable rocket ever constructed, a machine that could either revolutionize space travel or become another footnote in the annals of ambitious endeavors that fell short. Chapter 6. Starship's Final Act, SpaceX's Make-or-Break Moment. October 13th, 2025, marked this date. If all proceeds according to plan, and with SpaceX, that is never a certainty, the world will witness the 11th test flight of Starship, the tallest and most powerful rocket ever built. However, this is not merely another launch. Flight 11 will be the final deployment of the Starship version 2. Subsequent flights will feature larger, more potent, and theoretically more dependable iterations. The critical question is whether version 2 can conclude its testing phase on a triumphant note or if it will contribute another explosive event to a year already replete with them. Let us address the obvious issue. 2025 has not been a favorable year for Starship. The year commenced with 2 consecutive catastrophic failures that significantly eroded confidence in the entire project. Flight 7 in January saw the upper stage, known as SHIP, experience a complete structural failure. During its initial engine burn, 4 of its 6 engines shut down prematurely, resulting in a loss of attitude control and a total cessation of telemetry. The vehicle's disintegration was observable from Florida, Jamaica, and the Turks and Caicos Islands. Flight 8 in March initially appeared successful. The Super Heavy booster was captured by the launch tower's mechanical arms, a remarkable achievement. However, Ship 34 suffered 4 engine shutdowns during its burn, lost control, and disintegrated 9.5 minutes after liftoff. Then came Flight 9 in May, which utilized the program's inaugural reused Super Heavy booster, another significant milestone. Yet, once again, the upper stage failed to complete its assigned mission. 3 consecutive failures, 3 ships lost, 3 investigations, 3 rounds of redesigns, and repeated assurances that the next attempt would be different. Flight 10 in August finally broke the streak of setbacks. Everything functioned as intended. The booster splashed down as planned. The ship completed its suborbital trajectory, re-entered the atmosphere with its heat shield intact, and executed a controlled water landing in the Indian Ocean. It even successfully deployed Starlink satellites during the flight, a crucial demonstration of capability. For the first time in months, SpaceX and its proponents could collectively exhale. Now, Flight 11 is scheduled for 6:15 p.m. Central Time on October 13th, launching from Starbase in South Texas. The mission profile closely resembles that of Flight 10, but with several key modifications that render it more ambitious and potentially more perilous. The booster being utilized, designated B-15, previously flew on Flight 8 in March. It was successfully captured by the tower during that mission, indicating it is flight-proven hardware. This time, it is equipped with 24 flight-proven Raptor engines, meaning both the booster and the majority of its engines have already withstood the stresses of launch and landing. However, here lies the innovation. Instead of attempting another tower catch, B-15 will perform a novel landing burn engine configuration that SpaceX intends to implement on the next-generation Super Heavy version 3. The booster will ignite 13 engines at the commencement of its landing burn, then transition to a new configuration employing 5 engines during what is termed the divert phase. Previously, This phase utilized only 3 engines. The new 5-engine approach introduces redundancy to mitigate issues arising from unexpected engine shutdowns, a persistent problem encountered on several flights. Finally, the booster will transition to its 3 central engines for the conclusion of the landing burn, entering a full hover above the Gulf of Mexico before shutting down and descending into the water. SpaceX characterizes this as a stress test, aiming to measure real-world vehicle dynamics as engines shut down and restart across the various stages of the burn. If successful, it validates the approach for version 3. If it falters, at least the failure will occur over water rather than near the launch site. The upper stage, Ship 38, carries its own ambitious objectives. It will deploy 8 Starlink simulators, mock-ups designed to replicate the size and mass of the next-generation Starlink satellites that SpaceX plans to launch commercially. These simulators will not function as operational satellites. They are on the same suborbital trajectory as Starship and will disintegrate upon re-entry. However, their deployment will test the mechanisms and procedures required for actual missions. Ship 38 will also attempt to relight one of its Raptor engines while in space, demonstrating the capability for maneuvers beyond simple coasting. This functionality is indispensable for future missions to the Moon, Mars, or any destination necessitating precise orbital adjustments. Following this, the heat shield will undergo a test, a deliberately perilous undertaking. Engineers have deliberately removed tiles from several areas of Ship 38 to stress test vulnerable points across the vehicle. Some of the missing tiles are located in regions lacking a secondary ablative layer beneath. Should the plasma generated during re-entry penetrate these gaps, it could breach the structure and precipitate catastrophic failure. Nevertheless, SpaceX requires precise knowledge of the weak points and the extent to which the ship can withstand stress before failure. The only viable method to ascertain this is to push it to its limits until a failure occurs. Assuming Ship 38 successfully navigates re-entry, it will execute a dynamic banking maneuver. During its final descent, testing subsonic guidance algorithms essential for future flights returning to the launch site. This will be followed by a landing burn and a splashdown in the Indian Ocean, ideally intact. All these preparations are geared towards version 3, the Starship iteration that SpaceX believes will ultimately render the system operational. Version 3 ships will be larger, possessing increased propellant capacity and greater payload volume. The boosters will feature more engines and generate even more thrust. Crucially, the design incorporates lessons learned from 10 preceding test flights and countless failures, explosions, and near misses. However, the significance of these advancements is contingent upon the outcome of Flight 11. Should Ship 38 disintegrate during the heat shield stress test, critics will seize upon it as definitive evidence of Starship's fundamental flaws. If the booster's novel landing burn configuration proves unsuccessful, it will cast doubt on the viability of the entire approach. Should any significant failures occur publicly, it could jeopardize SpaceX's partnership with NASA, an agency that relies on Starship for the crucial task of transporting astronauts to the lunar surface during the Artemis 3 mission slated for 2027. The stakes are exceptionally high. Starship represents more than just a launch vehicle. It is the cornerstone of SpaceX's ambitious vision for the future of space travel. Its intended purpose is to democratize access to Earth's orbit, making it both affordable and commonplace. Furthermore, it is envisioned to facilitate the establishment of human settlements on Mars, revolutionize the deployment of satellites, enable in-orbit refueling, and ultimately propel humanity on journeys beyond Earth, ventures that currently reside within the realm of speculative fiction. However, before any of these grand objectives can be realized, the program must first overcome its persistent challenge of in-flight anomalies. Flight 11 presents SpaceX with a vital opportunity to demonstrate that its second iteration can conclude its flight record on a triumphant note, thereby building momentum towards the subsequent generation of Starship. The designated launch period commences on October 13th. Millions will be observing, and in the hushed anticipation preceding ignition, a singular thought will resonate universally. Please, let it succeed. While SpaceX diligently works to perfect its colossal spacecraft, another nation is actively pursuing a mission that has already traversed billions of miles from our planet, targeting an object that may hold clues to the moon's tumultuous ancient history. Chapter 7. China's Lunar Enigma. The ambitious endeavor of Tianwen-2. On May 28, 2025, at precisely 1:31 a.m. local time in China, a Long March 3B rocket ascended into the nocturnal sky from the Xi'an Satellite Launch Center in Sichuan Province. While this event garnered minimal global attention, the payload it carried into space could potentially unravel one of the most perplexing riddles in our immediate cosmic vicinity. Could a fragment of the moon be orbiting Earth, masquerading as an asteroid? The spacecraft in question is designated Tianwen-2, marking the second mission within China's program for planetary exploration. Tianwen-1 successfully reached Mars, deploying an orbiter and a rover that continue to function effectively. Tianwen-3 aims to retrieve samples from the Martian surface, potentially preceding NASA's own challenging Mars Sample Return Initiative. Tianwen-4 is slated for a dual visit to Jupiter and Uranus within a single mission. However, Tianwen-2 is focused on a much closer and considerably more enigmatic target, an object known as Kamo-Olewa, or asteroid 2016 HO3. Kamo-Olewa is classified by astronomers as a quasi-satellite, a near-Earth object that exhibits an apparent orbital path around our planet, despite its actual orbit being around the Sun. Its orbital mechanics are synchronized with Earth's in such a way that, from our vantage point, it appears to playfully dance around us, never venturing too far afield, nor being irrevocably drawn away. This asteroid measures between 40 and 100 meters in diameter, roughly equivalent to the size of a Ferris wheel. It completes a full orbit around the Sun every 365 days, mirroring Earth's orbital period almost exactly. This peculiar celestial ballet has been ongoing for at least a century, and possibly for a much longer duration. What truly sets Kamo-Olewa apart, however, is its spectral signature, the way it reflects sunlight, which bears a striking resemblance to weathered lunar rocks. In 2021, astronomer Ben Shai spearheaded a study proposing that this asteroid might, in fact, be a substantial rock ejected from the moon during an ancient impact event. The name Kamo-Olewa originates from a Hawaiian creation chant that speaks of an offspring journeying independently, a poetic analogy for a lunar fragment adrift in space while maintaining proximity to its celestial parent. If this theory proves accurate, Kamo-Olewa could offer invaluable insights into the moon's bombardment history, revealing the magnitude and energy of impacts that have shaped its surface, and potentially providing untainted samples of lunar material untouched by Earth's environment. Nevertheless, an alternative hypothesis exists. Kamo-Olewa could instead be a main belt asteroid that, through gravitational interactions not yet fully comprehended, migrated into a quasi-orbit around Earth. This scenario would be equally compelling, shedding light on migratory pathways within the solar system that current models do not predict. The only definitive method to ascertain the truth is to physically visit the object and collect samples. This is precisely the objective of the Tianwen-2 mission. On June 6th, slightly over a week after its launch, the China National Space Administration released the mission's inaugural progress report. The spacecraft was functioning nominally and had traversed over 3 million kilometers from Earth. An accompanying photograph, captured by an engineering camera, depicted one of Tianwen-2's solar arrays against the stark backdrop of space, confirming the spacecraft's operational status and well-being. Tianwen-2 is currently undertaking a year-long voyage to Kamo-Olewa. Upon its arrival in 2026, it will dedicate another year to orbiting the diminutive asteroid, conducting close-range observations, meticulously mapping its form and surface, and determining its mass and composition. This undertaking presents extraordinary challenges. Kamo-Olewa is the smallest asteroid ever targeted for a space mission. Furthermore, its rotation period of 28 minutes makes it the fastest spinning celestial body ever visited by a spacecraft. Landing on an object of such minimal size and rapid rotation is akin to attempting to alight upon a carousel in motion while blindfolded. China intends to employ 3 distinct sampling methodologies. The initial approach involves a hovering maneuver, wherein the lander synchronizes its rotation with that of the asteroid to collect material. The second method is a touch-and-go technique, analogous to the successful procedures utilized by NASA's OSIRIS-REx and Japan's Hayabusa 2 missions, where the spacecraft briefly contacts the surface, acquires a sample, and immediately ascends. The third, and most ambitious, strategy incorporates drills integrated into the lander's legs, designed to anchor the spacecraft to the asteroid's surface. thereby enabling a more controlled and extended sampling period. The primary objective is to collect a minimum of 100 grams of material, slightly more than 3 ounces. While this quantity may seem modest, when sampling an asteroid located 40 million miles from Earth with a robotic probe operating autonomously due to communication latency, every gram is exceptionally valuable. Once the samples are secured, Tianwen-2 will commence its homeward journey. In 2028, approximately 2.5 years post-launch, it will approach Earth and deploy a re-entry capsule containing the collected asteroid samples. This capsule must withstand entry velocities of 12.1 kilometers per second, exceeding anything previously experienced by lunar return missions, and generating temperatures and pressures that will rigorously test the capabilities of Chinese heat shield technology. However, the mission's ambition extends even further. Following the release of the sample capsule, Tianwen-2 will not be retired. Instead, it will leverage Earth's gravity for a slingshot maneuver, propelling itself onto a transfer trajectory toward an entirely different destination, the main belt comet 311P, Pan-STARRS. This interplanetary transit is projected to take approximately 7 years. If all proceeds as planned, Tianwen-2 will reach the comet in the mid-2030s, enter orbit, and conduct remote sensing studies of this peculiar hybrid object, exhibiting characteristics of both asteroids and comets. The entirety of this mission is designed to span a decade, 1 spacecraft, 2 distinct targets. It involves returning samples from a quasi-satellite, followed by a rendezvous with a main belt comet. This is a daring and intricate endeavor, and if successful, it will showcase capabilities possessed by only a select few nations. More significantly, it represents a direct challenge to American preeminence in space exploration. While NASA grapples with budget constraints, workforce reductions, and political interference, China is executing a meticulously planned and well-funded program of robotic exploration, steadily advancing towards increasingly ambitious objectives. Tianwen-2 launched precisely on schedule. It is functioning normally, and by 2028, it may deliver the inaugural samples from Kamo-Olewa to laboratories on Earth. Should these samples validate the asteroid's status as a lunar fragment, China will have resolved a significant scientific question and demonstrated its technical prowess in deep space operations. If NASA's Mars Sample Return program continues its protracted development while China successfully retrieves Martian material and subsequently rocks from an asteroid, the symbolic ramifications will be undeniable. The space race has not concluded. It is merely entering a new phase, one characterized by a constantly shifting finish line and competitors pursuing vastly different strategies. China is playing a long-term game, methodically building capabilities, launching missions, gathering data, and proving that sustained, patient investment in space exploration yields substantial rewards. Currently, Tianwen-2 is millions of kilometers distant, and its separation from Earth increases daily, propelled by solar radiation and ion thrust towards a destination few have ever heard of. Yet, when it arrives, when it collects its samples, and when those samples return to Earth, the world will take notice. At that juncture, another nation will have achieved what only the United States, Japan, and now China can claim: the successful retrieval of material from beyond the moon. Meanwhile, as China steadily advances its space program with clear objectives and stable funding, the American Space Agency, once credited with landing humans on the moon, faces a crisis that threatens to dismantle decades of achievements and jeopardize missions already in progress. Chapter 8: NASA's Crisis, Shutdowns, Layoffs, and the Battle for Scientific Advancement. At 12:01 a.m. on October 1st, 2025, the United States federal government officially entered a shutdown. Within hours, 15,000 NASA employees received furlough notices and were instructed to cease their work. Laboratories fell silent, offices were shuttered, and ongoing research ground to a halt. For the vast majority of the agency, all operations ceased. However, this did not apply to everyone. A small contingent of NASA's workforce, just over 3,000 individuals, were designated as essential personnel and required to continue working. They will not receive salaries during the shutdown but will meticulously log their hours, anticipating retroactive pay upon the government's reopening. Their continued presence is mandated because their work is directly instrumental in maintaining the operational integrity of spacecraft. Mission control operations for the International Space Station proceeded without interruption. Ground controllers diligently monitored life support systems, prepared and validated commands, and responded to any emergent situations. Approximately 1,000 commands are transmitted daily from Earth to the ISS to ensure its continued operation and the safety of its crew. Any furlough of these controllers would place the astronauts' lives at considerable risk. Thus, they continue to work without remuneration while congressional budget deliberations persist. The other significant exemption from the shutdown pertains to the Artemis program, NASA's initiative to return humans to the moon. Acting Administrator Shaw Duffy articulated the agency's priorities with unmistakable clarity in a social media post preceding the shutdown. China is not going to the moon with good intentions. The implication was evident. Achieving lunar surface presence ahead of China was deemed a national security imperative, significant enough to exempt thousands of personnel and contractors from furlough. This measure encompasses employees involved in Artemis II, the crewed test flight around the moon scheduled for as early as February 2026, and Artemis III, the actual lunar landing mission slated for mid-2027. It also includes contractors at SpaceX and Blue Origin, who are developing lunar landers and associated hardware for the program. These contractors were instructed to continue working through the shutdown, meticulously documenting their hours without immediate compensation, as any further delay to Artemis is deemed unacceptable. However, the full extent of NASA's predicament extends far beyond the immediate impact of the shutdown. The crisis at NASA predates October 1st by a considerable margin. Earlier in 2025, directives were issued by the Office of Management and Budget and acting NASA administrators mandating a reduction of over 4,000 employees from the agency's payroll. From the conclusion of September through January 9, 2026, numerous long-serving NASA employees are departing through deferred resignation offers, representing permanent separations rather than temporary furloughs. This translates to over 20% of NASA's workforce being gone. And this exodus is not solely defined by numbers. It includes individuals possessing exceptional expertise, engineers who contributed to Artemis systems, scientists overseeing planetary missions, and specialists in critical fields such as power generation, propulsion, and life support are among those departing. One NASA employee at the Johnson Space Center in Houston, speaking anonymously, indicated that the agency has lost at least one of its preeminent authorities on power systems, a critical deficiency for the development of the nuclear reactor necessary for lunar power generation. This wave of resignations is being fueled by economic uncertainty and political pressures. The fiscal year 2026 budget request represents the lowest NASA funding level since 1961. When adjusted for inflation, the very year Alan Shepard became the first American in space. The proposed budget includes a staggering 47% cut to NASA's science programs. If enacted, this would result in the cancellation of 41 missions, including spacecraft already in operation and actively making discoveries. Consider this: 41 missions would be terminated, not merely those in planning or development stages. These are missions currently in flight, telescopes observing distant galaxies, probes exploring other planets, and satellites monitoring Earth's climate. The proposal would effectively deactivate spacecraft that have been traversing the solar system for decades, squandering billions of taxpayer dollars and forfeiting knowledge that can never be recovered. The list of endangered missions reads like a compilation of humanity's greatest explorations. The Nancy Grace Roman Space Telescope, a flagship observatory designed to identify hundreds of thousands of exoplanets and survey over 1 billion galaxies, faces cancellation despite being nearing completion. OSIRIS-APEX, currently en route to study the asteroid Apophis during its close flyby of Earth in 2029, would be grounded mid-mission. The Mars Sample Return mission, despite having samples waiting on Mars for retrieval, would be abandoned, potentially allowing China to surpass the United States in returning Martian material to Earth. Even missions that have demonstrably proven their value are not immune. The Chandra X-ray Observatory, which has been observing the high-energy universe since 1999 and has made discoveries that have profoundly reshaped astrophysics, is under consideration for termination. The Hubble Space Telescope, perhaps the most renowned scientific instrument ever constructed, might experience a reduction or complete elimination of its mission support. The proposed budget cuts extend beyond space exploration. Earth science missions that monitor climate change, track deforestation, measure sea level rise, and provide vital data for weather forecasting and disaster response are also targeted. Planetary defense programs focused on identifying and tracking asteroids that pose a threat to Earth would experience diminished funding, an ironic development given the recent unexpected flyby of asteroid 2025 TF. Whistleblowers within NASA have voiced concerns, asserting that imposing a budget that has not been approved by Congress is unlawful and contravenes constitutional principles. They contend that NASA's legal counsel should recognize that the current administration's actions violate NASA procedures, regulations, and congressional intent. Nevertheless, these transgressions persist, often concealed from public scrutiny. The human cost of these reductions extends beyond NASA employees. Universities nationwide depend on NASA grants to fund research and support graduate students. When grant disbursements are halted during shutdowns or budget cuts, entire research programs can falter. Professors find themselves unable to compensate their teams, and students lose their funding mid-degree. Decades of accumulated expertise and institutional knowledge dissipate as individuals are compelled to abandon their respective fields entirely. UV astrophysicist Stephen McCandless from Johns Hopkins University, who oversees sounding rocket initiatives associated with NASA, has observed that the disruptions have significantly impacted funding availability. He has had to approach his university seeking emergency financial assistance simply to support an upcoming launch, and he is considered fortunate due to his employment at a major research institution with the resources to mitigate the impact. Smaller programs at less affluent universities lack such a safety net. Meanwhile, international partners are observing these developments with apprehension. NASA's collaborative efforts with the European Space Agency on missions such as Mars Sample Return and the Artemis program involve binding agreements and shared financial commitments. When NASA unilaterally alters plans or cancels missions, it strains relationships cultivated over decades and undermines America's standing as a dependable partner. Perhaps the most detrimental consequence is the erosion of public trust and scientific momentum. Space exploration is inherently a long-term endeavor. Missions require years or even decades for planning, construction, launch, and execution. It is not feasible to pause a planetary probe mid-flight and recommence its operations at a later time, nor can a mission to Jupiter be delayed by a year with the expectation that planetary alignments will accommodate the postponement. The principles of orbital mechanics are unaffected by budget cycles or political priorities. When continuity is disrupted, when programs are repeatedly canceled and reinstated, and when talented individuals depart without being replaced, the cumulative damage becomes substantial. Every canceled mission represents a lost discovery. Every departed expert signifies the vanishing of decades of accumulated experience. Every shutdown necessitates the arduous rebuilding of momentum from its inception. Nevertheless, hope persists. The space exploration community is actively resisting these cutbacks. Protests have been organized outside NASA headquarters in Washington, D.C., with employees and supporters demanding full funding and an end to the reductions. Lawmakers from both political parties, particularly those representing districts with significant NASA facilities, have opposed the administration's proposals. Both the House and the Senate have put forth appropriations legislation that exceeds the president's requested amount, although no final agreement had been reached as of early October. The critical question remains whether this resistance will prove sufficient. Will Congress assert its constitutional authority over federal expenditures and reject budget cuts that would jeopardize American leadership in space? Will the public demand that their elected representatives safeguard the agency responsible for the moon landings, the Mars rovers, the Hubble and Webb telescopes, and decades of discoveries that have expanded human knowledge and inspired generations? Currently, NASA stands at a critical juncture. One path leads to continued exploration, scientific discovery, and sustained American leadership in space. The alternative path leads to a managed decline, the cancellation of missions, the loss of invaluable expertise, and the observation from the sidelines as other nations surge ahead. This decision is not being made by scientists or engineers. It is being determined by politicians and bureaucrats, many of whom will never witness the repercussions of their choices firsthand. Meanwhile, Those who have dedicated their lives to unraveling the mysteries of the universe watch as their life's work is systematically dismantled. It is October 2025. Asteroids pass by undetected. Potential indicators of life remain frozen on Mars. Unidentified aerial phenomena appear in military footage without adequate explanation. The sun is progressing through its final active phase. Comets are hurtling towards us from the darkness. China is executing ambitious missions with clear objectives and stable funding. A private enterprise is constructing the most powerful rocket in history, while a governmental agency, once instrumental in humanity's lunar expeditions, struggles to maintain its basic operations. The universe remains indifferent to our budgetary debates or political disputes. It continues its ancient, immutable dance, unconcerned whether we choose to observe, to study, to explore, or to simply turn away and dismiss the cosmos as irrelevant. However, it is profoundly relevant. Every discovery we make, every question we answer, every mystery we unravel contributes to the collective sum of human understanding and serves as a poignant reminder of our place within something vastly grander than ourselves. At this precise moment, we are in peril of forgetting this fundamental truth, precisely when we need it most.